Good morning. Good morning, dear participants. Welcome to the session on artificial intelligence. Good morning, dear participants. Welcome to the session on artificial intelligence. My name is Daina Budonine. I am an assistant professor at the Faculty of Informatics at Kaunas University of Technology. And it is an honor for me to welcome you in this session. We will have an opportunity to exchange ideas about past, present, and future trends in artificial intelligence. And of course, we thanks a lot for co-organizers universities and wish you a very nice session here. So artificial intelligence session is organized fully online. Questions for presenters can be given in the YouTube channel. And here we have in total 7 presentations. And we are planning to finish this session at 12 a.m. I am sorry in advance if I will pronounce your names incorrectly. Just please improve me and introduce yourself in the correct way. So now we have the first presentation, which is by Guillermo Hernandez, Angelica Gonzalez, Rieta, Pablo Chamoso, and Juan Manuel Corjaldo. And we have a presenter, Guillermo. Please, Guillermo, the floor is yours, and you can share a screen and start your presentation.
Thank you, Professor Diana, for the introduction. I will share my screen in one moment. There it is, something like that. Yes, and now you should see the presentation. Well, first of all, I would like to thank the organizers for the opportunity of to share our work in this Congress, in IVUS, which is about mapped supervised learning. This is our work done with my colleagues Angelica González Arrieta, Pablo Chamoso, and Juan Manuel Corchado. So it was a good guess by Diana with the pronunciation of our names. I'm sorry if they are hard. Okay, let's go to see the content. I will summarize all the work in this abstract. This is a work to present a new ensemble method for supervised learning, which we call the mapped supervised learning. This is an approach to train a same learner, a same model in multiple disjoint subsets of data to enhance the predictions and also perhaps the explainability of the resulting models. We will show the formalism, we will show an example of how it can be applied to a simple problem, and give a short account of future work which it suggests. So, well, let's start with the introduction. As I said, this is a modeling tool that fits well into the paradigm of ensemble methods, which are typically composed in averaging methods. These are methods like the random forest or Bayesian aggregation, which aim to improve a model by joining their prediction. Independent learners are trained, and then a single prediction is produced to improve the results. Another common approach is the boosting methods, which includes examples like AdaBoost or the famous gradient tree boosting, which attempts to progressively reduce the bias or the errors of a learner by using misclassified instances of previous models. This method we proposed, or we are working on, involves fitting independent models with the same base learner or perhaps different learner, but to keep it simple, we will just focus on the same. This has the advantage that it can be easily parallelized because it does not depend on different, on previously built models with the learner, and perhaps it can contribute to the explainability of the models. This can be also a more general approach, as I will say at the end, at the conclusions, that can be applied to other paradigms of machine learning, such as unsupervised learning. To provide a quick description, I first will follow the formalism of Werner et al., which is a very recommended reading, in my opinion, for the foundations of modern machine learning. That it describes any supervised learning model, such as an application, mapping some collections of instances and labels of any number. So that's the reason of this union here, to some application from X to Y. This is very general. This doesn't say much about the how it works. It usually works by minimizing some kind of loss, typically the quadratic loss for one-dimensional regression problems. But how it works is not relevant to our purpose. It's just enough to treat them as some kind of application like that to build this ensemble. And this has many things in common with the unsupervised learning approaches, which is what makes the formalism useful, in my opinion. The idea of our method is to use any surjective mapping, so any function which could serve to map the instances of the set of the origin of the data, which is the input to the final function, to decompose them into some disjoint subsets which recover the original space. So typical examples of that could be categorical attributes or splittings made on a continuous attribute. It's very general. It's perhaps even too general. That's why this is called mapping ensemble, because any map, any function that adheres to this description can be used. So the formal description is over there, but the general idea is just that, training the learner on the disjoint data sets and at the end aggregating the predictions. As stated here, okay, this is a supervised model as well, and as I said before, the choice is too general. It could be a matter of hyperparameter fitting procedure to choose a nice mapping function, as perhaps choosing natural maps, as I said before. So the evaluation we have performed, we have done it by modifying this well-known, almost classic data set, which is a wine data set. It was originally intended to predict some class and discrete class label using 12 numerical quantities. Here we have reversed the situation, and we create 12 different problems in which we try to predict some of that quantitative measures by using the rest of the attributes. And the label is precisely what we have used to define the mapping to split in the dataset into those disjoint datasets. This is interesting because it can be regarded also as some kind of imputation building task. So it has realistic applications. Now, for the regressors we have used, to keep it simple, we have picked the common examples of supervised regression found in scikit-learn. This is a list of the algorithm we used. Those based on forest will have a different behavior, as we will see later. And the mapping was chosen as the projection of the first attribute. So the choice of the categorical attribute, which was originally the label of the problem. Now, to compare these problems, since they are different, we will use the R-squared coefficient, which is defined from -infinity to 1, 1 meaning perfect predictor, 0 equivalent to the baseline. To the baseline predictor, which always provides the mean value of the target. Now, to make this statistically rigorous, we have used the methodology proposed by Dietrich, which consists of performing a certain split in the cross-validation to avoid cross-dependence among evaluations. So this is useful because we have at the end some t-statistic which can be used to decide whether the differences are relevant or could be just due to the splitting, and as a statistical artifact. We will show both the results picking those statistically significant results, and also those who are not. However, it is also important to know that experiments where both models provided an score of less than 0.1 would be excluded, because it makes no sense to keep that models in a realistic scenario, because they would be replaced by a baseline model. So this just won't appear. Now the results are something like that. In subfigure A, all of the results are shown, but only those statistically significant according to the Dieterich t-test are shown in the right part of the figure. So sometimes large increments are found. The models in which these increments are found are those which are not based on trees. And why is that? This is not surprising, because trees precisely find those kinds of splits. They would decide, okay, split using that categorical attribute. It is natural that they do not improve, but it is worth improving the rest of the model, because with a simple choice, here the only categorical attribute, so it was a clear choice, made huge improvements. Even in the baseline model, which shows that sometimes the concept of baseline should be rethinked. Now this is a summary of just what I said, that some models benefit in a large amount, 3 models behave as I said before. And just to finish with some conclusions, we have defined this mapping supervised learning. We have evaluated it in a simple data set. We have also used this successfully in more realistic data sets, but for the scientific work, we prefer to stick to some openly available data sets. We have found that it can improve some models, and with tree-based models, it is not a surprise that they do not improve. We are working on another approach to make them able to improve using this kind of ensemble technique, and as it's listed here. And furthermore, we also attempt to apply this to different paradigms of machine learning, because it is a general approach, and unsupervised learning such as clustering can also benefit of this kind of decomposition. And about the references, those which I most recommend are this, which is a good summary of foundations of modern deep learning and machine learning in general, and the Dieterich methodology for the t-test. Well, that's all. Thank you for the opportunity to present my work, and I'm available for questions if there are any.
Thank you very much. Unfortunately, we have no questions in YouTube, but I will have one for you. So you mentioned mapped supervised learning paradigm that was selected for your research implementation. Have you discussed other alternatives, or do you think you choose the most appropriate way for your mapping-based subproblem decomposition scenarios?
Well, it is actually an open question, because as I said, any mapping could be chosen. A reasonable choice would be to keep it simple. So that's why in the wine example, there was only one categorical attribute that was a natural choice. And it also gives some sense of I should replace the baseline. Because in a real scenario, well, people without knowledge of machine learning will naturally split the data in different categories and see the category and extract some indicator. That will be precisely a baseline regressor mapped using the categorical attribute. So that was a natural choice. Of course, in a realistic scenario, we could and we should resort to hyperparameter tuning and rigorously test if there is enough data available, different mappings, and then we would be confident that we have made a good choice.
Thank you very much, Guillermo. Thank you. And now we have another presentation. The second presentation is on comparison of neural network efficiency learning process in relation to Wordor's activation functions by Paulina Halatek and Pavel Norris, and presenter hopefully will be Paulina Halatek. Please, so Paulina, please share the screen and start the presentation.
I will be the presenter. We will both try to present it to you. Thank you very much for the introduction. So do you see the screen, the presentation?
Yes, please, you can start.
Okay, so good morning, everyone. Again, my name is, give me a second for a video. Okay. Good morning, everyone. My name is Paweł Noras, and today with my collaborator, Paulina Hałatek, we wanted to show you the presentation about our paper, which title is Comparison of Neural Network Efficiency, Learning Speed in Relation to Various Activation Functions. So what is the purpose of our paper? As you might know, artificial intelligence has become a very trending topic, especially in recent years. It has the potential to revolutionize the way we live and work, and it has already begun to transform many industries. One of the components of artificial intelligence is a neural network, which is a type of machine learning algorithm. They are vastly used nowadays, for example, in situations like image classification, speech to text found in many text editor these days, and automotive industry, for example, in self-driven cars and many, many more. And activation functions are a crucial component of neural networks, as they determine whether a neuron should be activated or not. That means that they directly influence the output of each neuron and tell us if it is important in the process of prediction. In addition, another factor that can impact the efficiency and accuracy of learning, of neural network learning, is learning rate. And by carefully selecting these two parameters, you can achieve the best results for a model you develop. That's why in our paper and presentation, we want to focus on performance of different activation functions with several selected learning rate values. And at the beginning, we will describe which dataset will be used and a brief description of our neural network model. After that, we will analyze collected results of the experiments we performed and try to find some relationships between each activation function and learning rate value. So I'll give voice to Paulina right now.
At the beginning, we want to present some crucial things related with our article. First of all, what is neural network? A neural network is a subset of machine learning process that helps in advanced way decide predictions about a given data set. The idea of creating a neural network was inspired by biological nature of neurons that are in a human brain. The concept of the biological nature are much alike because the main purpose of the neural network is to try to mimic the way the biological neurons signal each other. In our article, we decided to create a simple neural network that contains with only one hidden layer. Our neural network consists of one input layer. Can you switch the slide? Our neural network consists of one input layer with two nodes, height and width, one hidden layer that has 4 nodes from H1 to H4, and output layer that carries information about predicted values of a given input values. For our neural network, we decided to take a simple data set, which describing people's gender based on 2 features, weight and height. The data set is available on kaggle.com and contains of 2,000 samples. Since we wanted to create a simple neural network, we decided to create a binary classification, which at the end of the classification, there is only 2 possible outcomes, one for male or 0 for male and 1 for female.
Yeah, so coming to the results of our experiments, these are actually the results in one big table. I know they might be a little bit overwhelming at the moment, but I want to give you a brief description about what next slides will be. And in each slide, we'll analyze different learning rates separately and plot of the learning curve of each activation function. The activation function that we are using in our experiments are tan, sigmoid, relo, and Gaussian, as you can see on given image. We'll try to compare 2 metrics, the loss function value at the different iteration thresholds and accuracy of overall model using a given activation function. At the end, we'll try to find some correlations between all of our conclusions gained by analyzing each different learning rate separately. So firstly, learning rate 1.0. In the given slide, we can see that the lowest loss function value had very low activation function, but really close to it were sigmoid and tan Gaussian. Gaussian clearly stands behind the other three when it comes to loss value and accuracy, as you can see on the top right image. On the ReLU, tan, and Gaussian plots, at the beginning of the learning process, we can see more or less jumps in the chart, which means that possibly the learning rate for those activation function was too high and caused the model to overshoot the optimal solution. Another very odd thing happened for Gaussian function. We suppose that the learning rate is too high for this particular function. Therefore, the model was getting worse over time. We can claim that the learning rate was too high, as I mentioned before, and caused the model to overshoot the optimal solution, like at the beginning for tan and ReLU function as well. For learning rate 0.44, we can conclude that the tan function has the best results. Before tan, sigmoid and ReLU have very similar results at the end, so they three are really similar and have very similar graphs as well. But we can see that sigmoid seemed to struggle a little bit at the beginning. It was learning a little bit slower. And Gaussian is still overshooting the optimal solution and clearly is performing the worst of all activation function for this learning rate. So learning rate 0.3. And for this learning rate, we can see that is actually really similar to the one before. Again, tan function has the best results, all of them, and that means that the lowest loss and accuracy. Sigmoid still is learning a little bit slower at the beginning, but is almost matching the accuracy of tan function. And the Gaussian is still overshooting the optimal solution. So for learning rate 0.1, actually interesting thing happened. Gaussian function finally does not overshoot the optimal solution, and the loss value in the activation function ultimately decreases. Accordingly, accuracy for Gaussian function increases as well, and even the accuracy of tan function, which was one of the best in the previous experiments. All of the functions perform very similar to each other, but sigmoid looks like its performance is decreasing with the lower learning rate. Since tan has the lowest loss function, but ReLU has the slightly bigger accuracy, and both plots of this function looks relatively the same, we've decided that both of them can be considered the best for this specific learning rate. Learning rate 0.01. So on the given slide, we can see that at the beginning, all functions are learning a little bit slower compared to previously examined learning rates. Clearly, the worst performing activation function is sigmoid, and our assumption from the previous analysis turned out to be true, that the lower learning rate indicate weaker performance results. Tan again has the lowest learning rate of all functions, but as before, it fell short a little bit with accuracy compared to ReLU function. So that will be the last comparison for learning rate equal to 0.001. And from given table, it can be concluded that the Gaussian function actually is the best, since it has the lowest loss function and the greatest accuracy. For other activation function, we can determine that when we decrease significantly the learning rate value, the model for each activation function was not able to make accurate predictions. Therefore, the slope of the function was being decreases very slowly, which means that it took a lot of time for a model to properly learn from a given data. Taking into account all plots, we can presume that the Gaussian activation function works the best when the learning rate decreases. So to sum up all the conclusions that we made through these few slides before, and through the analysis of these attained results for all activation functions, we concluded that actually there is not one simple answer that we wanted to actually answer at the beginning. There isn't one activation function that works the best in every possible scenario. But we are aware that the learning rate is a very crucial thing in creating neural network model, since when the learning rate is too high, it leads to a situation where the model may overshoot the optimal solution. This is what happened, for example, with the Gaussian function at the beginning. But when we decreased the learning rate, it started to learn a little bit better and faster. It didn't overshoot solutions anymore. But other thing that we saw, when we decreased the value, the model started to work properly. On the other hand, if the learning rate is too small, the model may learn very slowly. And we could see it, for example, when the learning rate was equal to 0.01 or 0.001. The accuracy for model was significantly worse compared to different learning rate values. And overall, we can actually identify some dependencies of examined activation functions for to learning rate value. Firstly, the most obvious one is that the performance of Gaussian function, like I said before, increases with the lower learning rate. Contrary, it could be observed that sigmoid function results tend to be weakened when the learning rate started to be lower. From this observation, we can gather some conclusion that we can gather some conclusions. When one deals with the higher learning rate value, it might be the best option to choose sigmoid as your activation function. But with the lower learning rate values, Gaussian may turn out to be the one best performing. If having to deal with something in the middle, we think that one can go wrong with ReLU and tan functions, because these two functions seem to have more persistent results through all experiments, but fall a little bit, but not much, short on very high and low learning rate values. Yeah, so as I mentioned, tan and ReLU functions are can be called somehow universal. And that will be all that we have prepared for you today. We found this project really interesting to create, to play with the experiments. Their results, like I mentioned at the beginning, weren't what we really expected when starting this project. So analyzing them was truly engrossing. And we hope you enjoyed this presentation and the results. And thank you very much for your attention. And do you have any questions?
Yes, thank you, Pavel. Thank you, Paulina. I have one question from this side. So you mentioned there's a paper that performed a series of tests of some of the same data group to establish the best learning rate for neural network model. Do you have concrete numbers of the tests you had to implement?
So the number of you mean the number of iteration of on the test? Yes. So for it was shown on the slide before, and the number of iteration was 2,000 for 20,000 for each activation function. But we also split it into parts to analyze what how each function will be performing at lower and the higher iterations. So, for example, it was shown on the lower learning rates that even 20,000 iteration wasn't enough for these activation functions and our neural network model to learn efficiently, and thus the accuracy and loss value, accuracy was lower and the loss value was higher actually.
Okay, thank you so much. Thank you for interesting presentation. And
Thank you very much.
I would like to ask, do we have a Ruben? Not yet. So we are going to the presentation, the first in the agenda. And it is intelligent medical decision-making for sepsis detection using reinforcement learning developed by Lashita Singh, Lanshai Kamra, Muskan Agarwal, Anya Gupta, and Ania. So who will present? Lashita, please, yours is yours.
Yeah, I'm starting the presentation. Just a few seconds. My screen is visible, right?
Yes, please, you can start.
Yeah. Good morning, ladies and gentlemen. Thank you for joining me today for my presentation titled Intelligent Medical Decision Making for Sepsis Detection Using Reinforcement Learning. My name is Lakshita Singh, and I am delighted to have this opportunity to share my research findings with you at this conference. So let's begin with the brief overview of the topic. What is sepsis? Sepsis is a serious and potential life-threatening condition that arises in response to an infection. It occurs when the body's immune response to an infection triggers widespread inflammation, which can lead to organ dysfunction and failure. Sepsis can affect people of all ages, and it is more common in the individuals with weakened immune systems, such as elderly, young children, and those with chronic illness. So basically, early detection and prompt treatment are crucial in managing sepsis. The standard treatment typically involves administering antibiotics to combat the infection and providing intravenous fluids to maintain body blood pressure and supporting organ function through respiratory support or other interventions as needed. So recent studies have shown that administering a 3-hour bundle of care for sepsis patients, including blood culture, broad spectrum antibiotics, and lactate measurements, can significantly reduce in-hospital mortality. So therefore, timely, aggressive treatment is essential in managing sepsis. Even experienced professionals face difficulties in diagnosing sepsis early and accurately, as its symptoms can be easily confused with those of other medical conditions. So, however, the electronic health record, EHR, captures the data that could aid in predicting sepsis despite the challenges and everything with the diagnosis of this condition. So early warning scores on the data from the EHR basically relies on, like, there are many scores like this. There are NEWS, there are SOFA scores, and there are Q-SOFA scores, etc., which are studied before this. So in my project, we are basically have generated the SOFA scores. So our study builds upon the previous research and seeks to enhance the likelihood of the septic patient survival in the ICU by utilizing the continuous state space modules and shaped reward function to identify the most effective course of actions. Our findings represents a crucial contribution to the field of sepsis treatment as they pave the way for personalized and real-time decision-making strategies that have potential to transform patients' outcome and reduce mortality rates. We chose reinforcement learning over any supervised learning or unsupervised learning because there is lack of consensus in medical literature on what that constitutes an effective treatment approach. So it is worth noting that reinforcement learning algorithms enable us to derive optimal strategies from training samples that do not correspond to the optimal behavior. Our primary emphasis lies in the development of continuous state space modeling, a sophisticated methodology that utilizes a patient's physiological data from ICU to represent their current physiological state as a continuous vector at any given instant. We use deep Q learning to determine the appropriate responses. So our study presents remarkable contribution in the patient's care, including the generation of treatment plans that potentially augment the patient's outcome and significantly decrease patients' mortality rates. So coming to the background research and the methodology that we have did. So as we know, like diagnostic success is difficult because its symptoms are very similar to the other illness, and doctors need better tools to make decisions at the bedside. And researchers have developed like various algorithms previously and various scores like News, SIRS, SOFA, QSOFA, and Rothman index to predict the clinical deterioration. So additionally, as you can see, the SERA algorithm produced the SIRS score, which was a component of initial clinical definition of sepsis. However, more recently, other scores like the recent scores, which we have included, SOFA and QSOFA, have gained so much popularity. And a few of the algorithms that were used were multitask Gaussian processes, and there are several studies that have utilized a model that is comparable to ours, but they have placed more emphasis on forecasting vital signs to predict the clinical instability as compared to the SERA algorithms. So coming to the data set, what we have used is a MIMIC data set to conduct a research. So it is a freely available data set which provides us with the comprehensive data. And this data is generally taken every 4 hours, and the data is recorded when several data points are present. And it is freely available on Kaggle also. The model we have used in our research is dueling double deep Q learning network. So it is basically the variant of DQN. And triple DQN minimizes the error between the target and the output. So that's why we use this model in our research. So we use neural approximation of Q star SA, which actually yields the optimal value function. The basic deep Q networks are not very efficient due to the problem of overestimation, which is very persistent in these networks, which generally leads to sometimes incorrect predictions and very large error ranges. And triple DQN minimizes the error between the target and the output. So this problem of overestimation is due to the presence of maximum value of the Q and to the next value of the Q, which is learning to update the equation. So this can be solved to the better variant of DQN, which is double deep Q network, where we actually calculated the Q value by the forward path, as you can understand a little bit from this figure on the main network, and using the main network directly, then calculating the direct Q values. So moving forward, let's directly dive into the results. So on the held out test, we measured it accurately on the 50 epochs. As you can see, the y-axis of the graph depicts the mortality rates, which fluctuate based on the variance between the recommended dosage dictated by the optimal policy and those administered by the healthcare providers, which serves as a return of action. The difference was computed and correlated with whether the patient lived or passed away in the hospital for each time step, as shown in the figure. So enabling the computation of observed mortality. So as you can see the figure above here, with a 95% confidence level, this bound would always be higher than the clinician's guidelines if enough models were produced. The statistical safety of the novel artificial intelligence policy in question is a topic of current disclosure in theory, which is maximized by this model selection method. So further concluding, the study we have investigated is fully continuous state space, discrete action space model to discover the most efficient treatment options, learning and estimate for the best action value function using dueling double deep Q networks. It was discovered that the resulting continuous state space model generated interpretable regulations that might enhance the sepsis treatment. The taught policies will be put through a patient evaluation and contrasted with other investigated algorithms in the future studies. The result of the study may significantly influence the medical practice for the sepsis identification. The use of a model like described in a paper can anticipate the onset of sepsis that could lessen the vexing issue of alarm fatigue that plagues the existing clinical scoring system. So actually improving the patient's outcomes and lessening the burden on the healthcare system, because sepsis is a condition that is poorly understood in the industry and is challenging for the practitioners even to diagnose. So although the focus of this work
sorry, Lakshita, for interruption. We lost you. Could you check your microphone? Lakshita, we don't hear you. Could you check your microphone?
Hello.
Yes, we hear you again. Please, you can continue.
So actually, I wasn't not audible before.
If you could start from the previous slides.
Okay. So just let me again get you through the results and the conclusion we have investigated. So basically, this study investigated a fully continuous state space discrete action space models to discover the most efficient treatment options, learning an estimate for the best action value function using dwelling double deep Q networks. It was discovered that the resulting continuous state space model generated interpretable regulation that might enhance the sepsis treatment. The taught policies will be put through a patient evaluation and contrasted with other investigative algorithms in future study. The result of the study may significantly influence the medical practice for sepsis identification. The use of a model like we prescribed, the triple DQN in the paper, can anticipate the onset of the sepsis that could lessen the vexing issue of the alarm fatigue that plagues the existing clinical scoring system, and can improve patients' outcome and can lessen the burden on the healthcare system, because sepsis is a condition that is poorly understood and is challenging for many practitioners to diagnose. And so although the focus of the work was clearly on the early identification of sepsis, it would be simple to adapt the techniques to other clinical events of relevance, such as cardiac arrest, code blue occurrences, ICU admissions, cardiogenic shocks. So basically, this would enable the practitioners to employ the techniques in real-world clinical contexts, and the model's usefulness can be objectively demonstrated by gathering information on the reliability of warnings it raises and how it is actually applied to the actual wards. So now I would be delighted to answer any questions you may have. Please feel free to share your thoughts or seek any further clarification on any aspect of my research.
Thank you very much, Lakshita, for your presentation. That is very practical and very necessary research you implemented. So we have one question for you. Of course, you had to analyze a lot of different data, probably very sensitive data. So what technologies were necessary for your data analytics during the research? Could you tell us?
So basically, we have used Postgres SQL for pre-processing of the data. So the data was very messy, and we basically using the PostgreSQL, we converted the data into the mimic tables. And from the tables, the data was directly extracted, and we used Keras for the further like the feature extraction and for analyzing the results, and PyPlot and Matplot library for further analyzing the results and everything. So many of the Python libraries were used, but main element was PostgreSQL because it actually helped us defining all of the tables and having the data what we actually needed.
Thank you very much, and thank you for presentation again. So now I would like to ask, do we have Antoni? No. So I would like to invite another presenters, computer vision based multi-cloud classification of garments using a three-level hierarchical approach. So here we have Asta Kvedaraite and Neda Vunevičiūtė and supervisor Agne Paulauskaitė-Tracevičienė. Please, floor is yours.
Hello.
Hello. You should. Okay, you should see me. And I will share my screen. Okay, so you should be able to see my screen.
Yes, everything is fine. Please continue.
Okay, great. So hello, my name is Asta Kvedaraite, and my colleague is Neda Buinevičiūtė, and our supervisor is Agne Paulauskaitė-Tarasevičienė. And we will present computer vision-based multi-class classification of garment using a three-level hierarchical approach.
I will present a problem. So the manual process of describing garments can be a time-consuming. It can be prone to errors, and Innovate solution can attract users. Our goal is to develop a hierarchical model that automates the classification of clothes. Next slide, please. Our model classifies garment into several classes, which are further classified into smaller parts. As you can see, the first layer, top, bottom, and full wear, and then each class is subdivided into more specific classes, like top is subdivided into shirts, blouses, and sweaters. The categories of second level are divided into very specific subsets of garments, which are likely to be most mixable because the garments are very similar. Our data set consists of 2012 images. The majority of photos in the data set are taken on mannequins, and it is high quality images. And this is an example of second level garment. Next slide, please. Each category was manually selected. Therefore, the size of each category will be different. In total, there are 21 categories. The largest category consists of 194 images, while the smallest category contains only 80 images.
So we performed a literature review and found that CNN Linet 5 had the best test accuracy, as well as CNN, AlexNet, and some others. So we decided that we would use Linet 5, CNN, and AlexNet models for our testing. And that's how it's presented. So the model first of layer 0, which means that all the data, all the pictures would be classified into 3 categories: tops, bottom, and full wear. In the model first layer 1, the top would be, all top pictures would be classified into shirts, blouses, and sweater. The second one would be model 2, still the layer first. The bottom would be classified into skirts and pants, and so on. And the experimental results of three-class classification, we found that AlexNet performs better than a non-hierarchical AlexNet model. As you can see here, even on the average. However, LeanNet 5 and CNN, both hierarchical and not hierarchical models, perform quite similarly. So we can say that AlexNet shows better that the hierarchical model classifies better in this case. Next one is 8-class classification. You can see that hierarchical models perform weaker for almost all blouses category class. And not hierarchical models perform sometimes better. Sometimes hierarchical models perform better, but on average, hierarchical models still do perform better. And for 21 class classification, we can see that all of them perform quite low. Still, the best one would be LeanNet 5 non-hierarchical, which has 47% of accuracy. And you can see that the hierarchical models like LeanNet 5 and AlexNet perform worse, except for CNN, which performs better for hierarchical than not hierarchical. Okay, and we also extracted a heat map of confusion matrix, and we can see that the garments are actually hard to distinguish. And the shirts and pants are most confused from this heat map. Also, dresses are classified as coats, and we do have a small amount of data, so not all classes are classified correctly. For example, this one, dress is narrow-sleeved, doesn't have any classes because it's a hierarchical model, and probably it just didn't classify anything at all. However, in non-hierarchical model, we have a few, although we don't seem to be correct, not all of them. Same one with CNN model. Most of them seem to be between their classes. Sometimes they do mistake, but it's in their subclass. Although CNN non-hierarchical model perform worse, and it just classifies or kind of randomly, and some classes also doesn't really have a lot. Same one with AlexNet. It just shows that between subclasses, it just do perform kind of better.
So as Asta said, the results of confusion matrices indicate quite low accuracy, which can be attributed to two primary reasons. Firstly, the sample size used in analysis, and secondly, it was highly unbalanced. Also, there was a noticeable degree of intermixing observed among the subclasses of shirt, long coats, short coats, and pants. And the results shown that hierarchical approach has the greatest advantage when classifying garments into 3 and 8 classes and allows an improvement up to 28%. For AlexNet model, the hierarchical model is significantly more accurate due to low accuracy of the AlexNet non-hierarchical model, which is only 58%. And the hierarchical model was found to be model dependent in the classification of the 21 classes, and 2 out of 3 models were found to be less accurate, and hence hierarchical subdividing is not suitable for LeanNet 5 and CNN architectures used in our research. So that is it. Thank you for your attention.
Thank you.
Thank you very much. Thank you, Asta and Neda. And we have one question for you. So you mentioned classification of garments using a 3-level hierarchical approach. Could you please tell us what was the biggest challenge for you during the research?
The biggest challenge, I would say that the biggest challenge was to choose to classify all the data set correctly, because some seem to be, let's say the dress would be pretty much like the code, and sometimes we just couldn't figure it out how the model would actually predict that value. And at first we thought that well, we did expect better results, but at the same time we had to understand that the pictures, the garments are hard to classify, also because of the small data. So yes, having small data does limit us.
Okay, thank you very much. Thank you for presentations. Hopefully that will be very useful for different organizations working in this sector. Thank you.
Thank you.
So now we have another presentation by Anthony Jazz. The impact of the weighting technique used on multimora-based ranking on patients using ambitious medical data. So please, Antic, the floor is yours.
Thank you. Okay, is the presentation visible?
Yes, go ahead.
Okay. So today I'll be talking about the impact of the weighting techniques on multimura-based ranking on patients using ambiguous data. And the presentation will be divided into 5 parts, first being introduction, then problem, solution, results, and lastly, conclusion. So I'll talk first about some methodology I'll be using today. The first being multiple criteria decision making, in short MCDM, which are analytical methods used for evaluating conflicting data, conflicting criteria, sorry. So to give an example, when we buy a car, we often look at the price of the car, safety of the car, age of the car, take all of those criteria under consideration, and then make our decision. So those criteria are what we call conflicting criteria, because of course, with high price, there is a better safety of the car tends to be, but we want the price of the car to be as low as possible, of course. And one of such methods is multimura method, which is often described as the state-of-the-art method, especially for uncertain development. The attribute weighting is statistical assessment of the importance of judged criteria, based on just values, not for example, on the opinion of the experts. And the data enhancement is a method of extending available numerical data by processing non-numerical data first. So let's talk about the whole multimura method and the decision matrix from the mathematical point of view. So decision matrix includes some M criteria and N alternatives. Each and every alternative has its own vector of X values. And for such matrix, we also need weights for each criteria, and the objectives, which is either to maximize or minimize the value. So going back to the example with a car, we would want our price to be as low as possible, while safety as high as possible, of course. And the multimura method consists of 3 systems: the ratio system, the reference point approach system, and the full multiplicative form, working together to find the best alternative. Unfortunately, due to the lack of time today, I won't be able to explain this further, but I highly recommend diving deeper into the method itself. The mean weighting is the most basic one we can have. It basically assigns the same weight value, which is 1mth, the m being the number of the criteria for each and every criteria in our decision matrix. And entropy weighting requires us to first standardize the values. So each and every xij value in the decision matrix becomes pij value by the formula shown on the presentation. And the end weight is calculated as follows, again shown in the presentation. So the problem at hand is a real-life scenario where a medical emergency is considered and patients needs to be assigned, assessed and ranked based on their need for help to provide those of the most need with the limited resources. So not long ago, we had a COVID-19 crisis, which resulted in many hospitals being faced with tough decision which patients should be treated first with limited resources such as respirators. This scenario is a horrible scenario to even imagine. And this overall solution presents an opportunity to eliminate the human-based factor from the assessment, which can be argued if it's, of course, ethical or not ethical. And the goals, the contributions of this paper and this presentation are a new approach for further enhancing the MCDM methods and providing a universal, well-performing solution for binary ranking problems. So let's talk now about databases we have. So in each and every database, in my experiments, there were two classes, the first being healthy patients and the second one being those diagnosed with COVID-19. And the symptoms database, the numeric database, consisted of 5 criteria: fever, body pain, age, runny nose, and difficulties with breathing, each with its own scope of values. And the visual data consists of lung X-ray image with corresponding masks and cough MEL spectrograms, which were then passed onto convolutional neural network in order to obtain a probability of a patient being ill with COVID-19 or not. So the whole solution is as follows: combining numerical data with processed non-numerical data in order to obtain broader database and ranking samples using cutting-edge Multimura method with prior attribute weighting. And in the research, the impact of 5 different weighting techniques for Multimura was tested. But again, due to the lack of time, I'll be only showcasing the most basic one, the mean method, and the one that gave the best results, which was the entropy method. The other 3 methods did better than mean method, but not greatly better, you could say. So the proposed solution is presented in the presentation. We've got numeric type data, image type data being passed and processed, then combined into one bigger expanded database, which is then weighted and passed on to Multimura, which then gives us the final ranking of the patients. So the expanded databases are as follows: the fully expanded with symptoms, X-ray, and cough, 2 with symptoms and X-ray, symptoms and cough, and lastly, the one with symptoms only. And the results are based on the top X graph, which basically tells us what percentage of top X patients in the ranking is diagnosed with COVID. So, for example, with the ranking of 2,000 patients, with 1,000 exactly being ill and 1,000 being healthy, the ideal graph should look like the one on the right. So let's see now how expanding the databases changes the overall score of the ranking. And as we can see, these symptoms did very poorly, while adding cough and X-ray enhanced the performance of the model, with symptoms with fully expanded being the best one. But we can even further improve the ranking, and the weight distribution is now displayed. Please pay attention again, mainly to the mean method and entropy method. And as we can see in the graphs on the presentation, the entropy method did improve drastically the performance of the ranking. And it can be seen in the fully expanded database, as well as partially expanded database. Really astonishingly improving the overall performance. And this can be also measured in metrics connected with those graphs. For example, mean absolute error and mean squared error, or area difference below the first half of the graph. So in conclusion, multimura method is a reliable tool for ranking applications. Enhancing data with processed non-numerical data can greatly improve the performance of the model, and entropy weighting can exceptionally improve the performance of the model. Thank you for your attention.
Thank you very much for presentation. It's very interesting and of course practically very well used. So the question from the site is, in the paper you mentioned that your proposed solution can be used in various types of systems where there is a lot of information on the basis. Could you please mention some examples? And as usually medical data usually is sensitive data. Had you any challenges working with the data for your research?
So I guess this method can be used in every scenario where we have to make a certain ranking. This was this scenario I proposed in the experiment was a drastic one, maybe a bit controversial one. But as I was giving the examples, we can use this method to make a ranking of the cars we want to buy, and basically in everyday solutions where we often have conflicting criteria.
Okay, thank you very much. And I see a question from participants.
Okay, I would like to ask one question. So what about the future works, and what should be the next steps of your study related with project?
I'm not really sure by now. I'd like to grasp everything I can, I would say. I think I'm the most interested in image recognition and image analysis. As you could see, even in this project, in those experiments, I used convolutional neural networks to process the image data.
Okay, thank you.
Thank you very much.
Thank you.
And now we have one more presentation. The last one presentation is on showcasing sentiment classification and word prediction in the quantum neutral processing area by David Pierre Garcia, Juan Cruz Benita, and Francisco Jose Garcia Bernal. So who will present, please? Floor is yours. David, are you the presenter for this paper?
Give me a moment. Do you hear me?
Yes, we hear you well. Please share your screen.
Okay.
If you would like.
Do you see fine?
We see agenda. If you will go to the slides and will you presenter view, development presenter view, so we will see everything well.
Is there any way? Give me a second to connect another screen.
Just open slides, yes. Okay, now? Now it's okay, thank you. You can go ahead.
Okay, hi, I'm David Peral Garcia, a PhD student from the University of Salamanca, and with the mentoring of Francisco Jose Garcia Peñalbo and Juan Cruz Benito, I'm going to present showcasing sentiment, classification, and word prediction in the quantum natural processing area. First, I am presenting an introduction, next a systematic literature review, and after that, I am giving a little explanation of the quantum natural language, and finally, two proof of concepts and the conclusions. To achieve faster computational speed than classical computing, quantum computing is rapidly evolving to become one of the most popular areas of computer engineering. The advent of noisy intermediate scale quantum devices or NISQ devices has made it possible to perform this work on quantum computers in, for example, areas like chemistry, finance, or machine learning. In the last one of the sub-areas of interest is quantum natural language processing, and one of the lines of research already allows us not only to encode words into qubits, also the association of the words with combinational circuits or ansatz. And this allows us, for example, to the insertion of the quantum circuits in the layers of a neural network. At the beginning of 2022, we published a systematic literature review in the quantum machine learning field. And this is a review of the literature published between 2017 and 2021 that was presented to identify, analyze, and classify the different algorithms using quantum machine learning and in their applications. Some of the main types of algorithms found were quantum implementations of classical machine learning or deep learning algorithms, such as supervector machines or quantum neural networks. Here, in the first image, we can see a quantum neuron, under it a backpropagation quantum neural network, and in the image on the right, we can see the application of a quantum neural network classifying 4x4 pixel images. Quantum natural language processing area is a relatively new area of research which uses NLP models together with certain quantum phenomena like superposition or entanglement to perform quantum language related tasks on quantum hardware. Bob Koch is one of the main authors of QNLP, who established the conceptual and mathematical foundations in this area, as well as the creation of different code libraries, like DiscoPy, DiscoCirc, or Lambek. For example, DiscoPy provides the code tools to define an intuitive syntax for string diagrams and monoidal functors. DiscoCirc is more focused in established interactions between the sentences. And finally, Lambek is a set of tools that facilitates the syntactic analysis, the rewriting, and the simplification of string diagrams. Also, the conversion of the string diagrams and the conversion of them into an ansatz or quantum sequence. Here we can see for example, the pipeline of Lambek, which includes the conversion from the sentence to the string diagram, the rewriting of them into normal form, the parameterization, which is converted to a quantum circuit, and the optimization of them. As a next step of the thesis, a first approach has been done with a small proof of concept, taking algorithms that are already used, that are already defined and tested with satisfactory results, but using them with different datasets. We use the sentence structure of the form noun plus conjunction plus noun plus verb plus positive or negative adjective. For example, in this case, Mary and John are cheerful, to classify the sentence into positive or negative sentiment. In the first image, we can see that the input sentences are taken from the dataset and converted into a string diagram. The resulting diagram in the second image is transformed into an ansatz or quantum circuit using the instantaneous quantum polynomial ansatz. And when this is done, the model is trained and we can achieve an 80% of accuracy in the validation test. Another proof of concept we made is on the word prediction area. Here we use the sentence Alice drinks water and try to predict what Alice is drinking. First, the input sentence are taken from the dataset as we do in the classification task and converted into a string diagram. When this is done, the diagram is embedded in the model, and the model is training using JAX, using the quantum simulation. And after the model is trained, we can observe that we have here an 18% of accuracy, which is not so much. So in this case, we have to improve it. And as a future lines on conclusions, through these small proof of concepts, it is possible that once quantum devices are developed and their size and quality are improved, significant results can be obtained with non-prototypical examples. And for future lines of work, it is proposed to expand the number of words that can be included in the same sentences or increase the complexity of the word association. Thank you so much for your attention.
Thank you very much for presentation. That is really very impressive. So we have one question here, and the question is related with the prediction. So there is a big challenge usually to predict more than one word for each sentence or without the grammatical context of the predicted word, and to which languages it is applicable your research? Is it just English or?
For now, just English. In the code library that I'm using, which is Lambek and DiscoPy, provides code tools to implement in Japanese too, but at least only the main focus area is English, but they are expanding to other languages.
And do you think this method could be useful for GPT as well?
Yeah. But you have to have you need to have a quantum computer in order to run it. So
Okay. Thank you very much. Thank you for interesting presentation.
Thank
And now we have one more presentation. The presentation is Kupami application for saving and processing DCOM images, and that is by Ruben Frail Sancho. Please, Ben, the floor is yours.
Hello. I will present Coupa ML, an application for receiving and processing DICOM images. Sorry. During the presentation, I will first give a brief introduction and then continue with related work in the field of DICOM imaging and artificial intelligence. Then I will explain the integration of imaging data with artificial intelligence techniques performed in Coupa ML. And finally, I will tell the conclusion obtained. By way of introduction, DICOM means digital imaging and communication in medicine is the standard for representing, storing, and communication medical images and related information. It has become one of the most popular standards in medicine. Initially, DICOM was used to communicate image data between different systems. The potential of artificial intelligence in healthcare has become evident in recent years with an increasing number of publications using deep learning and machine learning techniques for automated analysis of clinical data. Artificial intelligence system has been shown to achieve performance quite like clinical experts by providing clinical decision support tools. To be able to store an image, DICOM image in the healthcare sector, significant amount of platform has been created with the goal of easing the exploitation of these new paradigms. This is the case of Coupa ML, an application developed in previous research to allow users to train their own machine learning projects and analyze and interpret the result obtained without having expert knowledge on the subject by creating and executing machine learning pipeline visually. This work presents a new feature in Coupa ML platform where DICOM images will be stored, managed, and processed by providing an interoperable architecture with external packs. One of the motivations for applying this feature was to unify data from different sources and organize them into a more user-friendly structure. Over the years, DICOM has established itself as the leading standard for image data management in picture archiving and communication system. With DICOM software as subjects, image data can be visualized and analyzed by clinicians in hospitals and well as in clinical research. And if we focus on some of the software based on the DICOM standard management, we find several, but Cartier IA is one of those used for this project. Cartier IA is a platform framing the cardiology service of the University Hospital of Salamanca that unifies structured data and medical images, specifically DICOM images, to support researchers and physicians in the analysis associated with different studies, with a particular focus on supporting the application of artificial intelligence algorithms in images. The platform can be seen as a technological ecosystem that supports all data management related tasks and enables both healthcare professionals and data scientists to apply artificial intelligence models to the stored image. It is also based on different technologies and frameworks which are integrating using a server client-server architecture. If we focus on the integration of the application with PACS entities, the first thing I will do is a brief introduction of what these entities are. The name PACS comes from the acronym Picture Archiving Communication System, that is a system for archiving and communication of images, and its function is to streamline the processes of obtaining, managing, distributing, and storing medical images, benefiting both the health staff as well as the administrative and patients. In the developed application, this connection is made once the image search from Coupa ML has been filed in. To do so, the following scheme will be used to obtain the DICOM image. First, the JavaScript code will collect the data and pass it to the corresponding view of the application. This will request the image, it will pass the data to the configured packs, will respond with the name of the files. Once Coupa ML has the names, it will ask for the content of the image and their corresponding data sets as the name of the corresponding patent. The packs will respond, and when received, the view will respond to the JavaScript code with the number of images stored in the application. In order to integrate an algorithm into the platform, it is necessary to provide the previously trained model and the script that make use of this model in order to allow its invocation by the platform algorithm, artificial intelligence algorithm. Once an algorithm has been integrated into the platform, a button will be available in the image editor to apply an algorithm selected from those available for the current image. When the user confirms the request, the platform will produce the result, which, depending on the type of algorithm output, could result in this display of a new image. Once the process of integration the image to the application was finished, conclusions were obtained, such as being able to receive the icon image from other files, gives the platform several advantages, such as increasing flexibility or making connection between other users. In this way, user will have the possibility to analyze the DICOM image in a simple way and apply artificial intelligence algorithm or edit the image in a way that do not help from the experts. Thank you very much.
Thank you very much, Ruben, for the presentation. And probably the thing very important question for you as well about the medical data. Wasn't that a challenge for you to collect medical data, because this is usually sensitive data and that's important for our research to find out solution?
And the very important, because the medical staffs has I don't know ¿cómo se dice? How do you say, en plan, how I say mejorar? Sorry, I don't.
You're muted, Dina, you're muted.
Okay, thank you, Ruben. Thank you very much. I think we can close already this session because we finished already all presentations. Thank you, Ruben, for your
You're welcome. I'm sorry.
Presented here. And so we are closing this session. Thank you again for all presenters. I wish you best of luck, and we will meet with you at 12:15 if you will continue with us today in this conference. So thank you. See you 12:15 in the Lithuanian time. Have a nice day.
Okay, hello dear colleagues. My name is Audrius Lopata and I will chair this section, a special session on artificial intelligence and cybersecurity. Okay, so now I would like to invite the first presenter, Mindaugas Petkevičius.
Hello.
Could you please share your screen?
Sure. Can you hear me?
Yes, we can hear you.
Yeah. Sorry for the background. I'm at the conference right now, so yeah. So okay.
And please check the time limit. It's up to 10 minutes for presentation and 5 minutes for question and answer session, okay?
Okay, thank you. So I'm Mindaugas Petkevičius. I'm a student at the Vytautas Magnus University, PhD student, and I'm going to talk about fine-tuning language models for emotion recognition in Lithuanian text using neural machine translation of training datasets. So first I'm going to talk about the outline of this presentation. So it's going to be introduction, methodology, experiments, results, and conclusions. So the main problems right now that we're facing with the Lithuanian language is that the Lithuanian language is a low resource language to rich morphology, making it difficult to process using traditional NLP techniques. Lack of sufficient training data for NLP tasks is also a major challenge, as there are limited resources available for Lithuanian language. Also, the language models that we have currently are not trained on Lithuanian or just a portion of Lithuanian text, so it's hard to make and train language models for Lithuanian. Also, yeah, so therefore there is need to develop new techniques for NLP tasks, such as fine-tuning language models using neural machine translation. So the methodology, first we selected the dataset for the translation. We used 2 different translation models. Also, we used some augmentation process to enrich and balance the dataset, and we fine-tuned transformer-based models for emotion recognition. So yeah, so we selected the carrier dataset. It contains 20,000 English social media text samples, and the labels are sadness, joy, love, anger, fear, and surprise. We split them into 16,000 and 2,000 for the training validation testing. This dataset was selected because it's high quality and has quality annotations and diversity of emotions, and it's suitable for transfer learning and for translation. So the overview of the dataset, we can see that distribution of the labels and the length of the text. So as for labels, we can see that there are significantly lower numbers for the surprise, love, and yeah, so this would be an issue. And also you can see that, this is social media text, they are quite short. So this is just an example from the data set. You can see that, it's like short text and with some sentiment value in those. So yeah, so for translation of the data set. So the choice of translation service plays a crucial role in generating high quality translated data sets. To increase the linguistic diversity of the data set, we use 2 different machine learning translation models. So the first one was Opus MT. It's an open source neural machine translation model trained on a variety of multilingual parallel corpus. And the other was M2M 100. It's a many-to-many multilingual translation model developed by Facebook AI, and it supports up to 100 languages. by combining those two different translations, we aim to create a rich and diverse data set that covers a wide range of emotion and context. So yeah, so after translating, we wanted to assess the quality of the translations. So due to the morphology richness of the Lithuanian, achieving consistent translations can be difficult. However, as long as the main sentiment remains consistent, the impact is expected to the minimum. So training models on diverse translation styles can improve their robustness and performance in real-world scenarios. To assess the translation quality, we calculated the below, if you see this, yeah. So and the what error rate, the scores are displayed, but the scores show that there's significant difference between the translations, and so we can see that some examples of that translation. So, for example, there's original. When my wife told me that the refrigerator has stopped working, Opus MT translated, kai mano žmona pasakė, kad šaldytuvas nustojo veikti. Other Facebook model translated, kai mano žmona pasakė, kad šaldytuvas nustojo veikti. We can see the difference. There is a difference, and the level score calculates on token levels. So each different form of the word makes it different for that parameter. But we can see the sentiment of the text is the same. So yeah. So also, I'm the selfish person, and Lithuanian will be savanoriškas žmogus and egoistas. It's like almost like the same. So yeah. So for the balancing of the data set, we can see that love and surprise has quite low numbers. So we use augmentation that process. We used synonym replacement augmentation process. So first we tokenized the text. For each of the token, we took a vector of that word, and we searched for the most similar words based on that vector. And we tried to match the same part of speech and grammatical, and morphology. So the grammar of the sentence stays the same, but it's quite difficult. It's quite a different word, but grammatically it's a correct text. So yeah, and then we replace just random words from the text. So after the augmentation, we increased all those low numbers. So now the surprise, anger, and fear are almost identical. For language models, we took Roberta Labs and LittleBert. Solve the transformer-based models. LittleBert is the unique one because it's trained on Lithuanian and Latvian data sets. So it should perform the better. So the first one is that Roberta model trained on original data set. We can see that it's quite good, but for the translated and Lithuanian ones, it's LittleBert scored the most better, and the other got lower scores. So yeah. So also added some examples. For example, kas bus ateitis Rusai got the label fear. Aš bijau dėl savo ateities also fear. Man patiko šiandienos pamoka love. And you can see that it's the model performs quite well for Lithuanian, despite being translated on the English datasets. So yeah, so this study marks the initial effort to translate and adapt training dataset for downstream NLP tasks in the Lithuanian language. While we did not achieve the same performance level as a original dataset, our findings demonstrate that the models can be efficiently trained and translated on the metadata for Lithuanian context, and the data augmentation using synonym replacement is effective method for enchanting and performing robust emotion identification in lower resource languages like Lithuanian. So yeah, so thank you. Questions?
Okay, thank you for interesting presentation. And I would like to ask one question. So probably in the second slide, you listed at least 5 problems related with your research. And what is the biggest challenge in your work, I mean, in the scope of research?
I think the biggest challenge is the lack of training resources, because to train any model for sentiment analysis, for summary, for any task, NLP task, we have to have lots of training data. But right now, for Lithuanian language, we doesn't have any training data. Or some maybe organizations have some data, but we don't share those data. So it's quite hard to to make any NLP, some models to. Yeah.
And okay, what about the closest competitors like ChatGPT or something?
But it's for Lithuanian language, ChatGPT can work. It's like really limited. It can make some grammar grammar mistakes, and the sentences can be structured differently. Right now, you can try using ChatGPT, but the results will disappoint you, I think.
Too much specific, Lithuanian language.
Yeah.
Okay, thank you very much. Thank you for presentation. And next presenter should be Lucas. Lucas, can you hear me?
Good afternoon, yes.
Okay, so could you please share your presentation?
Yes, sure.
Okay, the floor is yours.
Good afternoon. Today I'll present anomalous water use detection using machine learning. Now, water is essential for all forms of life, from microorganisms to humans, and it's used for a wide range of purposes, including drinking and agriculture. However, water scarcity is becoming an increasingly urgent issue in many parts of the world. And when there's not enough water to go around, ecosystem can be severely impacted. Also, water leakage is a significant issue that affects many communities worldwide. In addition to wasting a valuable resource, leakage pipes can also cause damage to buildings, infrastructure, and negatively affect your financial situation. Now, many existing systems for detecting water leak are not considered smart because they do not incorporate advanced technologies such as machine learning. And these systems typically rely on simple rules. Another limitation of many detection systems is that they're not fast learners. This means they may require a significant amount of data to be trained effectively. Also, many researchers, and while there have been many leaks detection models researched, not all of them have evaluated using comprehensive evaluation metrics. And this can be hard and difficult for others to compare and select the best one for their needs. Now, in research, there are many algorithms discussed, and one of them is traditional, and they're based on specific predefined user or expert rules. For example, one of them is based on mass flow, which takes into consideration the water that comes in a building, which must be equal to the water that leaves the building. Also, they're based on accelerometer or statistics. For example, many people use less water at night than during the day. Also, there are unsupervised methods, and they're designed to identify anomalies or changes in data patterns that may indicate the presence of leak. Also, there are semi-supervised methods, and they combine both unsupervised and fully supervised. Active learning approach involves an iterative process in which the algorithm selects the most informative data points and provides them to the user or expert to evaluate whether a specific point is a leak or not. And finally, supervised models, and they require that the data set would be all labeled. However, these algorithms may struggle to detect leaks in unexpected or outlier situations, where it can be difficult to construct a model that is capable to find all possible water leak scenarios. Now, in my experiments, I use these models and they're publicly available on GitHub. So all of them except SSDO are unsupervised. SSDO is semi-supervised. I used Diet, which is a project that gathered many users' water consumption data. So I used Diet hourly measurements of 92 households in Alicante, and also used my own data, which is in minutely measurements. Various scenarios were generated and included in the dataset at a program's runtime, and each assessment was performed 5 times, and each new time, a random water leak scenario was included. And the model was fit on 80% and tested on 20% of the data in a training data randomly and inclusively from 0 to 3. And in the testing from 1 to 3 leak scenarios were included. And each scenario had a chance to overlap and last between 5 and 180 minutes. I've included dripping pipe, broken main line, and leaking toilet, and many more scenarios. I also evaluated these comprehensive metrics. And the last one is shortened for early detection score. And the higher the value, the earlier, comparing to other models, this model can detect a water leak. Now, looking at the first experiment, I divided the data into specified amount of hour frames, which is from 1 to 6 hours. As we can see, as we increase the window size from 1 to 6, many characteristics improve, but the disadvantage is that the algorithm would not be able to detect the leaks faster. For example, if we take 6 hours, it means that our algorithm would be running every 6 hours. And while if we used 1 hour, we would be able to detect leaks quicker, but with the disadvantage of lower precision and other characteristics. Another experiment of different minutely frames. In this experiment, I divided the data set into 1, 5, and 10 minutes. And as we can see from the results, as we increase the minutes from 1 to 10, we reduce the precision and recall and other characteristics overall. Also, another experiment using different contexts. So I divided the data using contextual and non-contextual data. And contextual data takes into account whether a specific day is weekday or workday. And non-contextual data takes into consideration all days. It does not matter if it's a workday or weekday. As we can see from these experiments, contextual and non-contextual data doesn't impact the choice of characteristics, although some models did slightly better when the data was not contextual. And finally, in this experiment, I divided the data using 4 dimensions. So first dimension represents the average water consumption. 2 dimensions represent average consumption and longest water running period. 3 dimensions include minimum, maximum, and longest water running period. And 4 dimensions include all of the above. As we can see, all the models did way better when there was 2 dimensions, which is average consumption and longest water running period. To conclude, if we have a data set which is in hourly data frames, it's better off to increase the window size for a better accuracy and recall, but with the disadvantage to detect leaks slower. Also, if we have data in minute frames, it's better off using smaller window size for better accuracy, precision. Also, since I've used household data, contextual and not contextual data does not really make a significant impact of choosing one or the other. Also, for the most effective approach to detect a leak, it's better off using 2 dimensions, which is mean and longest water running period. And finally, in most cases, PCA outlier detector was the most efficient in detecting water leak. Also, and for future reference, it would be wise to include commercial building data sets, as this could affect the choice of some characteristics. For example, commercial buildings probably use way less water during weekdays comparing to workdays. And this way, the experiment using contextual and non-contextual data could provide different results. Thank you.
Okay, thank you for interesting presentation. And I have one question regarding the data set. You mentioned it in previous slides. So you said that you used data from 92 households in Alicante. Why Alicante?
Because
Beautiful city or what?
This was the only available data set I could have found for hourly measurements of water consumption.
Okay, and is it enough for measurements to use the data set of 92 households only?
Well, this is arguable whether it's enough or not, but as this was only available data, it gives pretty good idea of what algorithms we could choose in regarding detecting the leak.
Okay, thank you. Do we have more questions from remote colleagues? No. Okay, thank you very much. Thank you for presentation. And next presenter should be Tamari.
Yes, yeah. Hello.
Okay, could you please share your screen?
1 minute. Do you see my screen?
Yeah, we can see presentation.
Thank you. Hello, everyone. My name is Tamari Kocokidem, and I would like to present you our research, digital signature design using Verkle tree. We have quantum computers have the potential to break many of the public key crypto systems that are currently in use. We have developed alternative systems. They appear to shield humans against quantum attacks, but they are not practical because they have problems with safety and effectiveness. Our goal is to create a crypto system that will work with both classical and post-quantum cryptography, and they must be secured and effective. As we said, quantum computers will destroy conventional crypto systems which are used in many products, and we need systems to replace such everyday used crypto systems. It is possible to replace such systems with hash-based signature schemes, but they have security and efficiency issues. The security relies on the collision resistance of the hash functions, and they need other factors such as random numbers. We have hash-based one-time signature scans. Those security is based only on the collision resistance of the cryptographic hash functions, and these scans are particularly good options for the post-quantum era. A good example of this is the Lampert DP one-time signature scan. In this case, we have one-way function and cryptographic hashing function. And this Lampert DP one-time signature scheme generates signature KX, which is consistent of the string of 2 n bits. We also have verification key Y, and to calculate the key, we use the one-way function N. In case of signature generation, the document M is signed using the signature key X. The signature is a sequence of the n-bit strings of the range n, and they are selected as a message digest function D. The signature does not require the correlation of F, and the signature length is n power 2. In case of verification, we want to verify the signature of M, and verifier calculates the message digest D. This scheme generates keys and signatures very quickly. However, the signature is quite large. To decrease the size, we have other signature scheme, but the concept is to sign multiple bits in the message digest using a single string. Because one-time signature schemes are very inconvenient to use, because each key pair can only be used once, we have a mark crypto system to solve this problem. This system uses a binary tree to replace a large number of verification keys with one public key, which is the root of binary tree. This crypto system uses one-time Lamport signature scheme and cryptographic hashing function. We generate merge signature scheme key pair, and we choose the length of the tree. Then we generate key pair, and using them we sign or verify 2 times each document. XG is the signature key and YG is the verification key. The leaves of the merge tree, we have the leaves of the merge tree. The internal nodes is calculated according to this. A parent node is the hash value of the concatenation of its left and right child, and the public key is the root of the merge tree. To generate signature, to sign a message M, we first compute n bits then, and then generate one-time signature. The L-mark signature contains one-time signature and the corresponding one-time verification key. Merge signature verification, we have involves 2 steps. In the first step, verifier uses one-time verification key to verify D, and in second stage, the verifier checks the reliability of the one-time verification key. Merge trees are fast, but when the merge trees contain many nodes, we have merge rules that are large. To sign 2 times n messages, the height of the tree must be n, and the merge proof itself is a significant and extensive chain on our local storage. So we want to decrease the merge proof size. We have a Merkle tree, and Merkle trees are a powerful upgrade to Merkle tree, which allows us to have small verification. In the Merkle tree, we substitute cryptographic hashing function with vector commitment. In Merkle tree, we need the children nodes to compute path, but in Merkle tree, we need only small, first path and only small amount of additional information as proof, and this is the vector commitment. And we need only first path and only small proof vector commitment. And vector commitment allows the user to commit an ordered sequence of a key value, in which way we can later open the commitment at special position. And we have also position binding, which is for security. And we need in vector commitment, we have functions to update the commitments to commitment. We offer vector commitments based on LSA assumption. We have several algorithms. We have first key generation algorithms, which generate keys. The second one is committing algorithms, which output committing string. The third one is algorithms, which algorithm is run by committer to produce proof. That M is the use committed message. Next one is verification algorithms. We have also update algorithm which updates if message to different message, and we have a proof update algorithm which updates proof. And this verification process only once we need to define a public key. But the drawback of this scheme is that the public parameter size, the size of the public parameter is linear to Q. We have novel scheme. One times signature schemes are hard to implement since a different key pair must be used to sign each message. We had a scheme using Mark III, which is fast, but proof size is very large and hard for our local storage. We have a Mark III, and this can make greatly improve merge proofs. And in this case, the verifier simply needs to offer a single proof that demonstrates all parent-child ties between all commitments. And in this case, it's very fast to and reduce proof size. We used in our new scheme, we use Merck 3 instead of Merck 3. And we firstly we choose H, which is then the K pair is generated. We verify or sign 2 times H documents. And we use, in this case, Merck 3. And which is faster than Merck 3. In this case, document signature will be concatenation of one-time signature, one-time verification, and index S for the proof and the root commitment. And we have a new scheme. Firstly, we had a Merck scheme using Mertlis. Now we updated and used Merck 3. But for us, it's critical that our scheme to have post-quantum security. But unfortunately, nowadays, this scheme is based on RSA and can be broken by quantum computers. And we are improving this scheme. And in the future, we plan to create signature schemes that will use Merck 3, but we use lattices to build vector commitments. And after this, our scheme will be based on post-quantum assumption. Thank you for your attention.
Okay, thank you very much for interesting presentation. And I have one question. So your topic was related with digital signature design using Merkle 3, right?
Yes.
So what are the closest competitors from the technological point of view for your proposed methodology?
Yes, thank you. This topic, Merck 3 is already researched, but Merck 3 is a new concept, and there are currently small research in this topic nowadays. It is one of the first research in this topic, and especially in post-quantum schemes. There are other schemes in classical cryptography, but not in quantum.
Okay, thank you. Do we have more questions from remote participants? Not. Okay, so thank you very much. Thank you. And next presenter should be Sergey Simonov.
Hello.
Can you hear us?
Yes, I can. And can you hear me?
Yes, I can hear you perfectly. Could you please share your screen?
Sure, and I will also try to share my face if it's possible. Unfortunately, I don't have a webcam, so I will try to use it from my phone.
Okay.
Give me a second, please.
Okay, we can see you, but
now, and now I will share my screen.
Great. Perfect. Perfect.
The PowerPoint should be shared. So shall I begin? Right. The topic of my talk is utilizing the mouse jack vulnerability in physical assessments. But before I talk about what's the mouse jack,
Sorry, could you please, excuse me, could you please turn on to the presentation view of the slides?
Sure, it will be nice, I think. Is it good now?
I think not yet.
We cannot see the full screen.
Let me try.
Could you please press F5?
I have already done that. Looks like it just shows it from the different. Okay, 1 second. I have one more idea. Let me just reshare my screen. New share. So I will try to share the entire screen of mine. Okay, now it's kind of better, but still not really. Okay.
We can see the notes right now.
I see. I will share my different
Okay,
screen.
so look, maybe it is not a big problem. So could you please continue?
Yeah. Sure. Let's not waste the time. The topic of my talk is the mouse jack vulnerability and how to use it in physical assessments. But before I carry on, I'll tell you a story from one of my physical engagements. And it was a terrible mess. I went to the object, tried to capture the Wi-Fi handshake, no luck there. Phishing campaigns, no luck there. Lockpicking, no luck. So that day, I remembered one very interesting bug and exploit from 2016. I went home, I prepared myself, and the next day I came to the object. I gained a full control of the network, just like in few hours. Now, how did I do that? Let's speculate about it. How hackers actually do this and how can they perform this kind of attack? The most obvious thing is to use social engineering and the rubber duckies. Now, what is the rubber ducky exactly? It's the USB device which acts like a keyboard, and when a victim puts it in their USB expansion slot, some commands are being executed. But you will have to somehow deliver your rubber ducky to your victim. Maybe put it in the parking lot like in the Mr. Robot series, but I don't really think it's realistic. Maybe put it on their desks, not really realistic. And the idea is they plug the rubber ducky and they give the attacker the reverse shell or maybe a beacon if they're using the C2 command and control servers or something like this. But imagine what if we had the remote rubber ducky. That would be nice, right? And what if I tell you that this kind of rubber duckies exist? Actually, the exploit was possible because our client, our victim, sysadmin, was using the Logitech keyboard. You may ask, well, how does this can occur in a system compromise? I will tell you. Some devices, some human interface devices, which are working wirelessly, like Logitech devices from 2016 till 2019, and maybe others, are vulnerable to the mouse jack bug. The mouse jack is the family of vulnerabilities which affect the wireless keyboards and wireless dongles. So it is possible to perform the wireless keystroke injection using kind of dongles like this. That's the Crazy Radio PA dongle adapter, which can inject the remote commands to the Logitech USB dongles. Now let's talk about how this vulnerability works and why it is possible. When the mouse and keyboard talk to the computer, there are two types of packets sent to the computer. The one type is the keyboard keystrokes, which are obviously encrypted. Like if you type something like ABCD or maybe your passwords, if somebody eavesdrops, it's not nice and they will get your data. That's why they are being encrypted. And also you have the type B mouse signals. The right clicks, left clicks, mouse scrolls your position on X and Y axis. This type of traffic is not encrypted. And here comes the mouse jack bug. In the mouse jack bug, the dongle does not even validate what type of packets are being sent. Is this the type A or type B? So what you could potentially do is send mouse signals which contain keystrokes. Pretty genius. How can it be done? Well, you might use the Crazy Radio PA adapter. You may use some software-defined radio devices like HackRF1. You get the dongle, you search it up with its MAC address, you inject the commands, you send mouse commands which contain the keystrokes. And if we think about what can be done, the amount of attacks is really impressive. The most simple thing you can do is the reverse shell using traditional PowerShell or maybe some netcat, something really simple. What is really interesting also is no antivirus can ever detect this kind of attack because it's not actually a virus. It's not a software. We are just sending our custom commands to the dongle. It's absolutely legitimate. No keyboard, no mouse is treated by antivirus like a malicious. It's always a trusted device. So if we can intercept and inject some commands, it's like we are sitting right in the front desk of the victim and typing some commands. What else can we do? The PowerShell, reverse shell, fine, not interesting. We can also try to extract the Wi-Fi credentials if it's a laptop or if the computer has some Wi-Fi card with the data. We send the malicious commands through our Crazy Radio dongle or HackRF1. The script is being executed from the attacker server. Script is being sent to the victim. Victim sends the result of the script to the server, and then hacker can download the result. And the result can contain pretty much any command you could execute. Steal the Wi-Fi data, steal the data from the browser. It could be pretty much any file you would like to get from the victim. What else? The reverse shell, we already talked about it. We're sending the malicious command. The victim sends and receives the reverse shell from the attacker server, and then the attacker gains the access to the reverse shell through the attacker server. We cannot use it on the same level of the network because of the NOT and other technologies that can prevent us from getting the shell. Any other attacks? A lot. The keylogger installation, the Trojan installation, the C2 beacon installation, the NTLM hash extraction, maybe some cookie hijacking with website session extraction, new admin user, the remote desktop protocol being enabled, a lot of things that we can do. But what are the drawbacks of this kind of attacks? Of course, the close physical proximity. We are hacking the wireless keyboards, so we have to be in like physical proximity of 10 to 50 meters Otherwise, we will not be able to intercept and send the commands as they are being executed through 2.4 gigahertz frequency, and it's not really a powerful thing. But we could try to amplify that signal using the directed antennas, and in the best case scenario, increase the range to 100 and 300 meters. Just imagine the situation. You have your typical data center and the sysadmin using the wireless keyboard. Without even penetrating the network physically, the hacker in a minivan with the directed antenna from 100 and 200 meters can send the keystroke injection and compromise whole data center. This is not really a pleasant thing if you ask me. This is not the bug that I have discovered, actually. All credits for this discovery goes to Bastille team, which discovered it in 2016. The bugs are being patched by the Logitech and other vendors that were vulnerable, but as it was already said by me, the mouse jack is not the bug of some vendors, concrete vendors, it's the bug overall. So if you ask me what's the relevance of the keystroke injection, I will say that there are, of course, a lot more vendors to research. A lot of vendors are producing wireless keyboards and mice like Defender, Trust, or Jambird, for example. These are one popular in my country. Maybe you have different vendors. All of these vendors can be vulnerable to the mouse jack. So if you're using your wireless mouse or a wireless keyboard, you might be vulnerable. There are a lot of devices that are still unpatched and the vulnerabilities are still not discovered. If we talk about the advantages, it's stealthy and quick. No antivirus shall ever detect it because, as I have already said, the keyboard is always legitimate device. No need to be in the same local network, which is really interesting. No need to intercept the handshake of the Wi-Fi, then crack it and enter the Wi-Fi network. This is not something that you need. You just have to be in a close proximity with your victim. And also you have full control over the victim operating system. Of course, the keyboard is being executed in the context of the current user. If it's administrator, you gain the administrator privileges. And guess what? Like 90% they will use the administrator account. What's the disadvantages? Well, the victim might use the Linux, the victim might use the Mac OS, and the victim might use the Windows. We cannot actually see this. We can only see the wireless dongle, and then we can try to attack it. If we are sending the Windows PowerShell command and the victim will be using the Linux, we will have no luck, unfortunately. So we will have to kind of guess what's the operating system of the victim is. I think it will be Windows, but it might be different. And also, what have I said? The physical proximity is required, but it can be fixed with using the directed antennas. To conclude my talk, the mouse jack and the keystroke injection is a really efficient vector of attack, but requires the victim to have a vulnerable hardware. It can be amplified using the directed antenna. You will have the instant root of the victim OS because that's what the user will be used on the victim OS. Really high probability of that. No antivirus spots the attack because the keyboard is the legitimate device, and the only way to stop this attack is just unplugging your vulnerable dongle from the machine. You can make it even more efficient if you host your payload on the cloud. It's more like a hacking topic. I will not go really deep into that. And the vulnerability is only and only patched when all the vendors around the globe patch the vulnerability in their devices. This wraps up my talk. And if you have any questions, I will do my best to answer them.
Okay, thank you. Thank you for interesting presentation. And all this talk was kind from the hacker's point of view, yeah? And and you're a bit scared at me. So what is your proposal? What I need to do in order to avoid all these vulnerabilities? Or that's it, I should, drop off my keyboard, mouse, and all these devices, and I don't know. What is your proposal?
That's really interesting question. If you ask me, I would always use the devices that are trusted and are being produced by some famous vendor, like maybe new Logitech devices or Amazon devices or Dell devices. I will definitely not use some third-party devices like Jamboard or Defender or these cheap Chinese devices. Of course, this is I never want to offend these vendors, but I want to emphasize that we have to work with the vendors that are that care about their security and that they protect their users. What else? Conduct researches, find these vulnerable devices, never use them. And if you ask me, never use the wireless devices anyways. I prefer wired keyboard. Here's my thick wire. That's my personal opinion on that topic. So if you ask me, you have to use some decent hardware to avoid this kind of attacks.
Okay, thank you. Thank you very much for interesting presentation. Do we have any questions from remote colleagues?
Yeah, hello everybody. I have a quick question. Yeah, first of all, Mr. Sergey, thank you for the great presentation. So, do we have any kind of information about like manual patching of that? Like, if I have an outdated mouse or the keyboard, yeah, wireless ones, is it any kind of a chances that I can patch it myself, or it needs to be patched by the vendor, and after I need to buy like a newer version of the device? Is it do we have such information about it? Thank you.
Sure. Thanks for your question. Of course, we have the information about that. It really depends on what vendor you're using. If we take the Logitech, their dongles have the capability of being patched with the firmware. So the Logitech have their official firmware that patches the vulnerability, so you can download and install it. But if you're using some less known vendor like the Defender and it appeared to be vulnerable, I'm afraid that you will have to just swap your keyboard for some new hardware, as these little Chinese dongles just don't have any capabilities of being patched or have the firmware installed on them.
Okay, great. Thank you so much. Thank you.
Okay, thank you for a very interesting presentation. And now I'm very glad to see my colleagues, my old friends, George and Maxim. Hi.
Hello.
Hi, Professor Lomata.
And now we will have some kind of mini section inside this section, because we will have two presentations from George and Maxim. And who will start?
I will begin.
Yeah. Today, Professor Audrius, first of all, my greetings from sunny Dubai.
Oh.
So glad to see you. Today I am not talking, only my co-workers are talking. But I entered to say hi to you with a big love and with a big respect.
Okay, it's very, very fine to see you, and thank you very much for providing as much as possible interesting presentations to our conference. Thank you, Maxim, and you are the best supervisor of the PhD students or the master students, so thank you very much. And now we will listen for presentation, and the presenter will be George Yashvili.
Okay, so Mr. Audrius, hello again. Thank you again for organizing such a great event. So even not being in Georgia, I am also in my business trip. So hello from Poland. So I am with you here. So excited to be. Thanks again. And I think we can start. So let me just share the screen. Okay, great. Can you see the screen?
Yes, we can see it.
Amazing. So let me just, okay. So today's topic is cyber intelligence capabilities through process automation. And we will talk about advantages and opportunities of that approach. So first of all, I want to emphasize that today artificial intelligence and machine learning is used very widely in different sectors. And our research is based on usage of that kind of approaches and mechanisms in OSINT, open source intelligent gathering. So very interesting thing today is that data gathering is used in a lot of different spheres, yeah, like beginning from cyber intelligence group, finishing with IT-oriented organizations, like and different sectors, yeah, law firms, ethical hackers, black hat hackers, etc. If we're talking about the range and the data sets based on the different information from open sources, we can get a lot, like different files, different kind of information about services, about organizations, about technical parts, about people. So a lot of information today is open. As we can know, for today, a lot of different technologies are used in that frame. Yeah, even Google uses different AI approaches in their searching to improve their searching mechanism. We have different platforms like TensorFlow to work with artificial intelligence. We have some different services like Gmail, Google Translate, which already implemented AI mechanisms, and they're developing themselves every single day. We have different streaming platforms like video streaming, like YouTube, with the recommender systems like suggestions. Yeah, for example, if we look for some kind of videos based on the concrete categories, it gives us more accurate and more relevant content to watch. Yeah. We have that in different directions, including different social networks, maybe. And we can say that here, the nice role has the intelligence cycle. Yeah, it's about interaction with the system, and it's already like oriented completely on the user sphere. Like it can interact with the user activities. It checks for the different actions, like what users like, what users don't like, what kind of feedback they can get from the user to send it in the better and accurate way. Of course, it will analyze, it analyzes the system, analyzes the behavior, collects the data about interests of the user, and after gives its feedback. Yeah. First of all, we have different kind of steps to perform. Yeah. And the first step is to understand the requirements of the user, what user needs. After that, we need to gather the information about the user and user activities if we're talking about some kind of a recommender systems, because in the frame of our research, we had to take into account different kind of methods, and the methods were used for recommender systems like movie databases, like travel stuff, etc., but never used for the security purposes. So data gathering process is very important. After that step, we have user-friendly format generation, because we need to represent the data in understandable way and format to make the user understand nicely what we want to provide the users with. And after that, the system needs to extract the information based on the relevant request. And after that, the system needs to distribute the result of this information to get more accurate results. Yeah. And after that, we have the final feedbacks. And I want to emphasize that feedback needs to be done from the both sides. First of all, we need to get the feedback from the user about the content, like was it relevant enough? Was the user satisfied with the result or not? And after that, system works with this concept and gives the result back already based on the collected data, and this data is analyzed and provided with the details with the user. Yeah. Here we have some limitations, of course, because it depends on the different situations, different search queries, and as we work with the open sources, not everything is accessible and reachable. Yeah, because we have limited data on the open sources. Of course, we have a huge amount of data, but not everything is in the open sources. And based on that, we can collect it using different automation mechanisms, including web crawlers and another kind of scanners. Yeah, of course, we can use manual methods as well, but it's more time consuming. So that's why in some cases it is better to work with the automated mechanisms. Yes, so we have some steps to perform here as well. We need to get some relevant nodes. We need to know what are the trusted sources for gathering information. We need to know the requirements based on the search queries, like to get the more accurate results. Of course, we can use here and need to use multiple sources to make sure that our information is more accurate and relevant. And of course, we need to work with the reporting activities based on some real world operations as well. And here I want to emphasize that we need to cover some stages to improve this kind of mechanisms concretely if we want to use them in the sphere of security based on open sources. Yeah, and from the first step, we need to identify the requirements, because it is very important to understand what user needs from the system. And on the last step, of course, we need to check if user gets the accurate data and the accurate feedbacks in the shortest time from that point of view. Here we have one of the concepts which is very interesting for today and very widely used, but I want to emphasize that it's used not for the security, and in the frame of our research, we concretely oriented on usage this content-based approach for content-based filtering approach for the security, and it works the following way. Like we have a special platform, like it could be a recommender platform with some actions in it. So we're monitoring the user activities. After that, we need to analyze them, generate the recommendations based on it. Working with a special recommender engine. Sometimes it might work with the remote server using API and collect the data from there, like send it to the server, and after receive it, more accurate data and give the feedback to the user. Yeah, a nice example of it is the Google search. If we will try to search something like cybersecurity news, we will get, of course, the results. And if we try to get something like news on cybersecurity, yeah, we will get the same results. So the sentences are different, but system can catch the main idea and the terms of our search query and give us very, very similar or the same search results. So because it understands the concrete term frequency and term weight. From that point of view, we are going to the concept of TF metrics or term frequency metrics, and it helps us in accounting of the terms in different queries. For that purposes, we need to use two main mechanisms based on the recommender system: term frequency or TF and inverse document frequency. And those mechanisms are used to work with a different type of the content. In the frame of our research, we had 3 different websites. We collected different terms like security, website, student, team, university, and design. And the data was as a plain and pure data, first of all. And after that, we worked with it based on some content-based filtering processes. And here we had the concrete terms based on this kind of inverse document frequency, because we have here the terms like the, of, or, is in the content. They are less important because they are not giving us the information about the content in itself. So we need to filter them out. And after using the formula, we are getting the concrete IDF, or in that case, it's inverse document frequency, and we can just compare the values to get the better and accurate results. Here you can see the formula when we can see that our TF or term frequency is damped. Yeah, why it is needed? Because here we have two types: the pure data at the first step, term frequency, and after our calculations, we are getting weighted term frequency. In that case, this kind of data and that values are more comparable. Yeah, and we can say it more accurately. By means of it, we can use special vector space model, and if you can see here, we have the terms. Yeah, I really like chocolate, and here I have different sentences like "have a great day" and "have a nice day," and these two sentences, they are much more relevant, close to each other than the other one. I really like chocolate. Yeah, so this concrete weighted term frequency gives us opportunity to better to compare these values better and see the differences and of course similarities to make it more understandable. And from that point of view, we can say that future of artificial intelligence, concretely in OSINT, from point of view of OSINT, is very close, and we're continuing working on that point. And we have already some results. We can say that different assistants like Amazon Echo or Siri, they from today, yeah, they still can. They already can collect the information about the user frequencies and after work with this data based on the concrete concept. Yeah, and as a conclusion, I want to say that when we are integrating artificial intelligence concretely in the OSINT, we might have higher accuracy in two main directions. Yes, better speed first of all, and better accuracy. And from my point of view, it will be great to have such a mechanism implemented in different products to get better result, first of all, for the user's point of view, and together with that, to improve the security overall. Because as we already know, when we work with the data in the frame of any kind of attacks, yeah, in ethical hacking, in penetration testing, even black hat hackers use these kind of methods with the collecting of the data very frequently, because more information we know about the potential victim, higher probability of the success. And concretely implementation of AI technologies will help to get these results in more accurate way, and of course to automate this kind of approaches. Thank you very much. If you have questions, please.
Yes, thank you for interesting presentation. I have one question. So in general, if I understood correctly, you presented kind of framework which is able to enhancing cyber intelligence capabilities through process automatization. It's kind of framework, yeah?
It's more like a model. Like we already have some.
Yeah, model. Okay, but it is you analyzed all these things from a theoretical point of view in general, yeah?
And we have some implementations as well. Well, I just built a special kind of a platform to collect the data, and now we are in a research process because mainly it's mostly interesting for the organizations. So we work with different organizations to work with like concrete cases to gather the information, you know. So when we are dealing with AI, it is important to find the correct parameters to work with, yeah. And for that point of view, we need some kind of information to like as a starting point. Of course, we use open sources, but for more accurate feedbacks, we need real cases as well based on the different organizations. That's why now we are in the process of it.
Yes, okay, but how you plan that the final product will look like? It looks like kind of a specific environment, including kind of dashboards or something, or how it will, what will be the final solution?
It's a nice question. Prototype we already have. It is the web platform with an interactive special form, and in that form you need to describe your concrete case. it works on that case and gives you the solution and suggestions based on your concrete case. But the interesting point here is that it's not based only on the concrete cases. It needs to be connected to the global open source databases like vulnerability databases, like OSINT databases, to provide us with the best practice solutions together with that. Yeah.
Okay. Okay, thank you. Do we have more questions from remote users? Not. Okay, thank you, George, very much for interesting presentation.
Thank you.
Thank you.
Thank you so much.
Okay, and next presenter, Georgie. Okay, so could you please share your screen?
Sure. Let me share the screen, and that's it. Could you see my screen?
Yes, we can see your screen.
Okay, thank you. Hello again, everyone. Thank you for your time, for giving me the ability to present my research results. My topic is high band related threats in 5G network. I'm Georgi Khalay, PhD student from Georgia Technical University. Also work with Scientific Cybersecurity Association of Georgia and making some cybersecurity researches at Caucasus University, and also managing the GNSS network of Georgia. That's how our research idea came with us. Let's start with a brief introduction. As you know, the development of mobile devices has extremely increased, which are already internet-connected devices. On the right side, you see the number of devices per user, which is internet-connected. And this also triggered to develop the 5G network and beyond standards. As you know, the new standards, functionalities, or services also arise a new cyber threats. So we started working and also, you know that the mobile devices are carried by users every time, daytime or nighttime. So we try to assess the vulnerability of 5G network, which is related to the end user privacy. It's related to the location-based services. Here's our key objectives of our studies. Does a new architecture of 5G network affects on end user location-based services privacy? I mean, if we can track end users without their prior permissions, which of the three operating spectrum represents more vulnerability for the users, and to assess this vulnerability, scale of the vulnerability. Start with the operating spectrum, which was a huge change between, if we compare 4G and 5G network standards. For 5G networks, we have three operating spectrum. The first one is a low band, which is operating for below than 1 gigahertz. It's less affected by the buildings and building materials, so it will be used for highly densely populated areas. But in that case, we are limited with the bandwidth. So the next operating spectrum, we need to increase the bandwidth. It is between 1 gigahertz to 6 gigahertz. The bandwidth is here higher, but it's more affected by the buildings than the previous one. And the last one is the high band. It was our target of our research, which will be operating spectrum from 6 gigahertz to 100 gigahertz, which is also known with millimeter waves. Actually, this operating spectrum promise all the general benefits of the 5G network. But the limitation is that it's highly affected by the building. And let's continue to see how we can use this to track end users with only one cell towers. Before this, I'd like to briefly explain the method of locating the devices. For different techniques, we have the same concept of locating. We need the reference systems by which we will calculate our locations. Usually, these are the GPS satellites or cell towers of our mobile network operators. Our device is trying to measure the distance by measuring the arrival time, frequencies, angle, and some of the other things that the signal strengths might be also used. So let's continue. Here's the two well-known methods being used when we record the signal sent by the GPS satellite. It's the most precise method in the Earth. This gives us millimeter accuracy. And the next one is the AGPS, assisted GPS, also known. It's used inside the building, so when we are going to calculate our locations. In that case, we know that the location of the cell towers, and we measure the signal received by these cell towers, and then making triangulation and trilateration to calculate our location. Cell towers of mobile operators usually share their information, their IDs, their locations, the frequencies, and all the unique parameters we need. So we can use already available open source software to make wide drive cyber attacks. I mean, to just start the software and go to the streets and locate all the cell towers. If we know this all locations of all cell towers, and we know the cell towers which are visible by user's device, and we know that user device is always scanning the cell towers for stronger signals, we can make a triangulation or trilateration and calculate the locations. So we know that this one cell towers, the distance of the coverage from one cell towers is another one, and this is a third one. If you know the location of three cell towers, this is a classic method how it is done. At this moment, we can calculate cross section, and this will our possible locations. But at this moment, we need three cell towers at least. Also, we need at least 3 GPS satellites to calculate user locations. But what happens when we are working with radio frequencies? Radio frequencies are used for the communication, and with the widespread of these techniques, technologies, the exposure levels of electromagnetic fields has decreased. There are some groups who think that it might affect our health. So there are some legislative acts that define the risk groups, like pregnant women or the workers carrying medical implants. There are some regulations which requires to use the building materials which will protect the buildings from radio frequencies. As a frequency is going through the buildings, if the materials are quite strong, which is making the good interference, this means that the frequency are limited by the buildings. So this limitation is also dependent on the frequencies. As I already mentioned, when we're talking about the high bands are most affected by these building materials. And we also know that if the users are still connected to the high band 5G network, I mean from 6 to 100 gigahertz, it means that users must be near to this kind of cell towers. Near means that it's about 100 meters radius. This means that after that we don't need 3 cell towers to calculate the locations. To summarize the limitations, we have the limitations of the buildings and building materials. We have the free space loss. This is a loss for the space which goes through the atmosphere or with the buildings. We have also limitations in the nature of the radio waves, and we have the geographic factors like terrains. Why it doesn't happen in 4G networks? Because 4G network is using the lower frequencies, which are less affected, and less affected than the high band networks. Also, we know that the attach process when a user is trying to connect to the mobile operators, this process is sent without any encryption. This is just to save the times. And if we go to the deep with the packet tracers, packet inspectors like Wireshark, for example, here's a different type of packets we are looking for. And just to go to this one, if we capture this request sent by user's device to the cell towers, we can find cell identifiers. If I know which cell tower is targeted by the user's device, I can redirect its request with the active sniffing and force user's device to connect every time to the high band 5G networks. If the user's device will be forced and will be connected to the high band mobile cell towers, and I know the location of cell towers, and also I know that if the user is connected, it's no longer distance than 100 meters, then it means that I know the location of the end users. So here's all the unique parameters. This research is done on the first generation network because at this moment we don't have 5G network in Georgia. That's why we are using, but the concept of connected to device to the cell tower is the same. Both of 4G and 5G using no encryption during the connection. To summarize our results, there is a chance that there is still no encryption during the connection. When we increase the frequency, we get high bandwidth, but we are limited with the distance and by the objects which prevents propagation of the radio waves. It means that we are limited by the buildings. Locating with the AGPS, with the cell towers of mobile network is less noisier than GNA satellites, and also we know that the device must be near to the high band cell towers to be able to connect and because of the frequencies. And if you know all this information, we can also collect all the cell towers in the city, and it means that as there is no encryption with the active sniffing, I can redirect user, not I, but we can redirect all the requests to the high band cell towers, by which I can calculate the exact location of the users. So the difference between the classic approach and this one is that we are not anymore, we do not need anymore 3 cell towers, only 1 is enough. And also it's more precise than using 3 cell towers. Because in case of 3 cell towers, the distance is so big, so cross-section area might be so big that we cannot determine where user is located. In our cases, the precision is about 100 meters. As a recommendation, according to studies, the user device should not be automatically connected to the high band 5G network. It should be connected to the low band or middle band, because they can spread their signal in longer distances, and in that case it's impossible to locate users by 1 cell towers, and the connection to the high band should be done by low band or middle band after user is already connected. So if a cell tower will automatically reconnect or make redirection from itself to the high band, it cannot be sniffed by the users, so it protects the end users. And also there is a second recommendation, so there is no need why high band cell tower should share its locations in a high precision like latitude and longitude, and also ID. Usually cell towers needs to share the locations to determine users location to calculate for emergency cases or military services, and some countries is already requiring mobile operators to set this parameter in high precision. But for 5G network, it will be big cybersecurity risk, so it should be removed from high band cell towers. So that's all I'd like to explain about our paper, the results. And if you have any questions, please.
Yes, okay, thank you for presentation. And okay, so I have one question. So 5G technology started in Lithuania, I think 2 years ago. And for example, me and my colleagues as regular users, we are using, let's say, 5G Smartphones, yeah? So could you please list the three most important things that I should know using this technology in order to avoid these threats?
No, at this moment, you cannot avoid these threats because the connection is automatically done by the mobile device software, because it's the standby process. The cell phones are usually searching, not usual, but every time is searching for stronger signals. So I mean that when you're connected to the cell towers and your speed is more than gigabit per second, you are under high risk that you might be tracked by someone who knows how to catch your traffic, because it does not depend on you, as the connection to the cell tower request is sent without any encryption. This is just to save the time. For the previous IVUS conference, as I remember, 2021, we presented the security algorithm, how this encryption can be done in a secure way design. I mean, at this moment, user cannot do anything about that because the process is totally automatically. It's a task of mobile service operators, like mobile operators.
Okay, thank you very much. Do we have more questions? No. Okay, thank you very much. And let's move to our last presenter in this section before the lunch break. So, do we have the presenter? Yes, Egle. Okay.
Egle and Bogdan.
Egle and Bogdan.
Yeah.
Great, perfect. So, could you please share your screen, and the floor is yours.
Hello everyone, my name is Bogdan, and with my colleague Egle, on behalf of the whole research team, we're gonna present our project. Phishing attacks are a serious threat targeting users through emails, messages, and fraudulent websites to steal sensitive information or damage system, resulting in identity theft, financial loss, or other negative consequences. In our project, we applied bird-based models for phishing detection in emails due to the increasing number of new means of influencing system being invented. We evaluated the fine-tuned bird-based models and their effectiveness in detecting phishing emails. The starting data set for the experiments included 186 emails, anonymized fish. They were anonymized. This information about links and attachments present separately. The email messages were divided into 7 main elements, such as sender's email address, subject, and category, among others. The phishing email dataset was analyzed and classified according to 7 data theft techniques, including social engineering, ransomware, and man-in-the-middle attack. Social engineering was found to be the most common technique used in the emails. The dataset was also categorized based on the targets of the phishing emails, with payment requests being the most frequently identified target. After the initial data set of 1086 phishing emails messages was prepared and analyzed, it was completed with additional data from publicly available sources. This new data consisted of 5,323 phishing emails messages and 6,403 natural or ham email messages. The resulting dataset was then used for fine-tuning pre-trained models to improve their ability to detect phishing emails. By incorporating this additional data, we were able to increase the size and diversity of the dataset, which ultimately led to more accurate and robust models.
Thank you, Bogdan. So let's move to our methods. So for the phishing detection, we used models which is called transformers. And the main points of the deep learning architecture is that transformers can process large amounts of data in a relatively short period of time. Also, it uses transfer learning methodology, which involves using a pre-trained language model as a starting point for training a new model on a specific task. And also it uses attention mechanism, which helps models to understand the context in text. And it's a huge improvement comparing with other machine learning methods. And in our study, we decided to use 3 widely used pre-trained deep learning models that uses the BERT architecture, which has been the most popular method in language technology since 2018. And specifically, we selected models that were pre-trained on the English language, namely the DistilBERT, TinyBERT, and Roberta transformers. And the reason for choosing these models is because the original BERT model has a large size, and making it impractical for many applications. So we decided to use smaller ones. So first of all, DistilBERT is already a smaller version of BERT. But for example, TinyBERT is even smaller with a size of only a few hundred megabytes, and making it ideal for low resource development. And talking about Roberta, it is robustly optimized BERT approach. It was improved performance on a wide range of natural language processing tasks, and particularly though it requires deeper understanding of language. And our experimental setup. So we fine-tuned our model 3 times with different random weights initialization seeds to classify emails as either phishing or not phishing. Also, we used 3 different models, as I mentioned before, and they were trained each for 30 epochs with a learning rate of 0.001. And also we used batch size, different batch sizes for different models. For example, if the model size is the smaller one, so we used the bigger batch size. So for example, TinyBERT, we used 64, the batch size. And the Roberta model was the biggest one, so we used 24. So in this slide, you can see the training parameters comparison. So you can see that Roberta type models were the longest to train because back one more back. Yeah. So Roberta type models were the longest to train since this model had the most complex architecture and was trained on more data than the 2 distilled learning type models like DistilBERT and TinyBERT. And however, most of the Roberta models also had the lowest training loss, which later resulted in higher classification performance. And the 2 distilled learning models both had a lower train runtime, and still the fastest to fine-tune was the TinyBERT model. And however, both models had higher training loss than the larger Roberta model. And in this slide, you can see the model's abilities to classify the emails into 2 classes. Is it phishing or not phishing? And all the performance were evaluated with 4 classification metrics: accuracy, precision, recall, and the F1 score. And overall, it can be observed that all of the models exhibit strong performance in classifying phishing emails.
all of the fine-tuned models attained scores above 0.9 for each metric. And nevertheless, the Roberta model demonstrated the highest classification score. And in this table, you can see the results of best models from each BERT architecture experiment. Testing with the phishing email database, which was fulfilled, as Bogdan before mentioned, that we filled and put more data in the dataset. So classified correctly column indicates that the model classified the emails as phishing, and the classified incorrectly column indicated that the model classified the letters as not phishing. And so, as we can see, that Distelbert and Roberta models produced very similar outcomes, and the TinyBird model had the worst results. And to conclude everything, so we can see that all the fine-tuned models attained scores above 0.9 for each metric. So it's a really good result for that. Nevertheless, the Roberta model demonstrated the highest classification scores across all metrics, and it indicates that it can classify the selected phishing data with the utmost accuracy.
Okay, thank you very much for interesting presentation. And my question is about the future works. What will be the next steps of your research and study?
So our future work is actually to work for Lithuanian language, because in English we can see good results, but in Lithuanian language it's much more complex task to do that. But now we got models that work well, so we want to try it yeah.
Okay, thank you very much. Thank you for all the presenters of this section. So now we're working according to the time schedule, and now we'll have a lunch break, and hope to see all of you at 2:30 p.m. to the next session, Intelligent Systems and E-Learning Solutions, Part 1. Okay, thank you very much. Lunch break. So, dear colleagues, hello, nice to meet you again. And now we'll start a special session on intelligent system and e-learning solutions, part 1. And my name is Audrius Lopata. I will be a chair of the session, and I would like to invite the first presenter. Do we have the first presenter? Neha Jain, or need to sign? Oh, we have. Great.
Okay, good afternoon, sir.
Good afternoon. Could you
This is
please...
Dr. Neha Jain.
Okay. I can see you.
Shared my screen. Yes. Should I share my screen?
Yes. Could you please?
Okay. Okay.
Yes.
Is my screen visible, sir?
Yes, your screen is visible.
Okay.
And could you please turn the presentation mode? So
Yes,
press
sure.
F5.
Yes, sure.
Okay, great.
Is it
Perfect.
fine, sir? Okay.
Yes, we can see.
Okay. Firstly, good afternoon to everyone present here. I want to present my research work in the conference. I have made the presentation on the topic an exploratory study of technopedagogical skills and happiness of prospective teachers in relation to generative AI. Am I audible, sir?
Yes, we can hear you.
Okay, fine. So as we all know that artificial intelligence has modernized the way of doing all the things. So keeping in view this perspective, we have conducted our research work on this topic. Generative AI is one of the type of AI and an extraordinarily effective technology, which is a form of digital technology that can generate innovative and realistic visual, textual, and animated content quickly. UNESCO mandates also ask for a human-centered approach to artificial intelligence, which aims to address existing inequalities regarding access to information, research, and cultural diversity. It is suggested that AI for all must be promised so that everyone can be benefited for innovation. Now we can see the relationship between the generative AI and education. In this part, in this slide, we can understand the role of generative AI in education. So through the generative AI, we can generate the questions on the level of the students, on the basis of level of the students. We can develop the personalized study plan for students as per their need. We can engage we can engage and our learners in the interactive learning activities, and we can also make the real-time feedback through the generative AI. So it is very helpful in today's perspective to include it in the education sector. Now in this slide, we can understand the contribution of generative AI in teaching learning process through three aspects, that is input, process, and output. As input aspect is related to the planning. So a teacher can make the planning. So teacher can prepare their content, personalized content, virtual tutoring, and gamification curriculum development through the generative AI perspective. And in the process aspect, generative AI is useful in making the student's idea innovative, in making the interactive teaching, and in creating the friendly and learning environment for the students. In output aspect, this ensures the accessibility of education to all. And it can also useful in increasing the teaching and learning efficiency. So these are some general applications of generative AI, which can be useful in the learning process. So these the major areas are the visual applications, audio, text-based applications, code-based applications, and some of the applications which is directly related to the education, and some other applications like conversational AI and the big data synthesis. Now, on the basis of the studies conducted previously and the use of generative AI, these two questions raised in the mind of the researchers: does generative AI effective for developing techno-pedagogical skills of prospective teachers? And second was, is there any significant effect of generative AI on happiness of prospective teachers? So before move on to the objective, I want to present a slide based on some of the generative AI based application which we are using in our teacher education program. Our students, that is our pupil teachers, are frequently working with these applications in the teaching learning process. These all are the generative AI based tools, which is already being used by the pupil teachers in the Albaik Educational Institute. Now, these two objectives were framed by the researchers. The first was to examine the effect of generative AI on techno-pedagogical skills of prospective teachers. The second objective was to investigate the effect of generative AI on happiness of prospective teachers. In the light of these two objectives, two hypotheses were formed. There will be a positive effect of generative AI on techno-pedagogical skills of prospective teachers. And the second hypothesis was there will be a positive effect of generative AI on happiness of prospective teachers, which were tested. Now, if we talk about the research methodology, the single group pre-test and post-test design was used in the present study, and the experimental research method was used. The sample of 330 prospective teachers was taken into consideration, and with this sample was selected by the systematic random sampling technique. Two psychological tools were used in the present study, and one was constructed, and the second was the standardized scale, which was developed by R.L. Bhardwaj and P.R. Das in 2017. The data analysis was done on the basis of mean, standard deviation, and t-test. So this is the research design, which shows that first we have selected the 30 prospective teachers. After that, we have conducted the pre-test of two psychological tests based on our variable. And after that, we have given the training of generative AI tools in teaching. And after that, we have collected the data on the basis of post-test. Now, this is the analysis of first objective, which was to examine the effect of generative AI on techno-pedagogical skills of prospective teacher. This table exhibiting the effect of generative AI on this variable. So we can see that we analyze the mean on the basis of the mean difference on the basis of t-test, and the t-value was found 4.93, which was significant at 0.01 level of significance. And we can also see the mean of post-test. It is very much high than the pre-test. So we can conclude from this analysis that the generative AI tools were effective in after the treatment, the techno-pedagogical skills of prospective teachers was improved. The mean value is showing that. And in the second objective, to investigate the effect of generative AI on happiness of prospective teachers, we analyzed this objective, and we found that the mean difference was significant, and it was analyzed through t-test. So the t-value was 7.8, which was significant at 0.01 level of significance, and we can say that the post-test value was 113, that is much high than the pre-test value. So the happiness of prospective teacher was found much higher than after using the generative AI tools. The present study revealed that after using the generative AI application, prospective teachers has gained more technopedagogical skills. The generative AI-based applications for creating real view of objects and providing different forms of learning content with 3D effect. Therefore, prospective teachers like to be skilled in technopedagogical perspective. It was also found that generative AI influences happiness of prospective teachers. The reason behind it may be that after using generative AI-based application in teaching, prospective teachers have created a unique form of content, interactive classroom environment, and creative ideas of teaching in very less time. So it is suggested that pre-service teachers should use AI-based application for making the teaching learning process effective. Thank you.
Okay, thank you. And I have one question. So in general, could you please comment on how the results of your research will be impacted by an appearance in the market of such the revolutionary, let's say, innovative solutions as ChatGPT and others?
In present scenario, it is a challenge because so many applications are there which can be harmful for the students, and we are also facing this. ChatGPT is students are frequently use the ChatGPT, but we try to give the exposure of the apps which are useful for them. So we also discuss with them the ethical side of AI. Because our pupil teachers will work with the students with a big classroom, the 50 or 60 students. If they will use these type of app, then the negative side we also discuss with them. So our focus in the Dayalbag Educational Institute is for value education also. So we integrate these two things together. And it is the demand of the present scenario because as the technology gives the exposure of various tools. So for example, a tool of generative AI is photo maps, in which we provide the question, the mathematic problem in the hard form, and the app will give us the answer. But this app is not useful for the primary level. So we, along with the training of these AI tools, we provide the ethical side of, we discuss with them. So we
Okay, so general, is it a problem for you or it is not at all?
In initial stage, it is a problem with us, but later on, student actually we in our university. We give the special sessions for that. We bring them at the evaluation level, in which we discuss with them that what are your views, because we don't pressurize them. We can't actually, if we are not allowing them to use these type of app in college or university, they will use these app at home. So as a teacher educator, we just give them the negative and positive, both the side. We discuss with them.
Okay, thank you very much. Thank you.
Sir. Thank you so much.
Okay, thank you. And our next presenter should be Dalius Gudeika. Do we have Dalius on site, online? It seems that we don't. Okay, so next presenter should be Mindaugas Vinciūnas.
Yes, I'm here.
Okay, Mindaugas, so could you please share your screen?
Yes. Okay, do you see my screen?
Yes.
So, okay, my name is Mindaugas, and I will present impact of dark and light mode graphical user interface modes on system usability, preliminary findings of an experimental study. So, first of all, possibly every one of us have seen that the dark modes, the tendency is growing, and more systems are suggesting dark and light mode. So what is dark and light mode is? Dark mode is when the background is dark gray or black, and while text and other interface elements is in white color or other light colors. Light mode is opposite to the dark mode when the background is white, and while text and other interfaces, interface elements used in the dark colors. So further motivation behind the studies, existing user interface guidelines do not sufficiently address the difference between the dark and light mode. Research in this field is limited and inconclusive. So the key known findings, so by study by Koenig and Jenger, there's the finding that there is no difference, there is no significant difference in user honesty between dark and light modes. Dark mode promoted honesty in users who had been awake for a longer period of time. Other researchers finds that dark mode led to lower trust and trusting intentions toward e-commerce websites. Nielsen-Norman group finds that users generally preferred light mode, but preference varied depending on the context and task. Dark mode suited tasks requiring less visual acuity, while light mode suited tasks requiring high visual acuity. It seems that there is more research on the aesthetics of the dark mode, but there is noticeable gap in the understanding the impact on the work efficiency. So the plan of this study was made with 4 steps. So the first step is that needs to formulate hypothesis and define measured variables. Other steps is to define the structure of the study, and it means to create experimental task, define questions, choose a survey system, create and implement graphical user interface elements, and implement the experimental survey on chosen system. The next step is to publish the survey and collect the data, and after collecting the data, analyze it and summarize the results. So for this research, there was 5 hypotheses. And the first hypothesis says that color modes affects the speed of working with the system. And other hypothesis says that color mode influence on the speed of working with the system depends on the age, depends on the user experience, on type of device, and color mode preference. So the structure of the experimental survey was from 6 steps. The first step asks for respondent age, second asks for browsing time, and after those 2 questions, the task is given to respondents, and after successful task completion, there are a few more questions. So 2 of them are associated with opinion about dark mode, and the last question is what kind of device they were using during the experiment. Also during the experiment, there was 2 tasks, and there's given design examples what we used. So the first task was to find an object in a list. It means product opening time. And submitting order data, it means form filling time. So in study, there was 62 participants included in data analysis, and 37 of them was using computer, and 25 of them was using smartphone. The majority of respondents' age was between 22 and 32 years old. Talking about browser's experience and preferred mode, 63% of respondents reported that they are browsing more than 2 hours. 35% of respondents reported that they are browsing about half and 2 hours, and only 2% browsing less than half an hour. 48% chooses the default mode, and 29% chooses dark mode, and 23% of respondents preferred light mode. Like I have said, there was two tasks. So one of them is product opening and other one is form filling. So the overall efficiency in different design modes was quite similar. As we can see in this diagram, in light mode, respondents done the task slightly faster. Talking about the next hypothesis, for example, with user age and product opening time, here we can see that there is no correlation between these parameters, but talking about form filling time, we can see that there is correlation in dark mode between user age and form filling time. And it means that if the age is increasing, the form filling time tends to be longer. What's about user experience? So more experienced respondents find and open the product faster than those, and for form filling task in the light mode group, less experienced participants manage to complete the task faster. Depending on the device, there's also some difference. And when using a smartphone, product opening time in dark mode was quite faster than in light mode. And it means that for respondents, it was easier to find correct product in the dark background. But for form filling, it seems that dark mode has negatively impact, and form filling time was longer in smartphones than in light mode. Depending on the user preference, those who prefer dark mode and were using a dark mode, product opening time was fastest than those who prefer default mode or light mode. For form filling time task, those who prefer default mode, they completed the tasks faster. So the conclusions, the preliminary results indicate that no significant or meaningful difference overall task completion time between dark and light mode. But when other variables were considered, certain trends and dependencies emerged, and all 5 hypotheses were confirmed, indicating that it's important to choose color mode based on user age, browsing experience, device type, and color mode. And the results highlight the need to take into user individual characteristics and preferences when designing graphical user interfaces modes to enhance work speed and efficiency. And for developers and system owners can improve user experience and productivity by selecting correct design mode. So future research directions, studies could explore additional factors such as color contrast, font size, and screen resolution, and their impact on different user groups. Of course, it would be better to make the respondents count more bigger and to get better statistical reliability. Task-specific investigations should be carried out to explore other scenarios beyond the chosen task in this study, such as navigation, and additionally factors like cognitive load, motivation, and emotional state could be considered in the future research to gain a deeper understanding of their impact on work speeding with the system. So That's it. Thank you.
Okay, thank you. I have one question. Your study was related with the age of the users, yeah? And I will try to ask a question. Okay, I am 47 years old and I'm starting my first e-commercial business and I need to create the portal. And in order to get the maximum financial benefit, should I choose dark mode design or light mode design?
So I can't suggest what to choose because this is a preliminary results. But in my opinion, it would be better to let the users to choose what mode to use in your system.
So it should be both of them, yeah? It should be optional for users, yeah?
Yes, I
But
think...
but the initial one, but by demand, which one should be? By default, which one should be presented?
By
one or
by default it would be still the light one.
light one?
Yeah.
Okay. Thank you. More questions? Maybe we have more questions from remote users. No. Okay. So thank you very much for interesting presentations. Thank you. Okay. So our next presenter should be Silvia. Do we have Silvia?
Hello, Professor. I'm here.
Yes. Okay. So Silvia, could you please share your screen?
All right. Can you see my screen already?
Yes. Yes, we can see your screen. Okay, great.
There we
We
go.
can see your screen and we can see you. Perfect.
Hello. Okay.
Okay, the floor is yours.
Okay, hello everyone. Hello, Professor. It's a pleasure for me to be here today presenting my project named Streamlining Subaquatic Rock Fabrication through Mathematical Modeling based on CAD and CFD analysis for enhanced performance. For our agenda today, will be divided into 5 stages, starting with an introduction with a method and data. We will have the mathematical modeling, our results, and conclusions. For our introduction, I can tell you that remotely operated vehicles called ROVs are underwater robots designed to accomplish tasks underwater. They are frequently utilized in a variety of sectors, including oil and gas exploration, marine research, and undersea exploration. Building a ROV requires detailed planning and consideration of several elements, including the environment which it will operate, the activities it will do, and the materials and components in its development. For our method and data, it will be divided into 2 base stages. We have the mechanical design based on CAD. This one, for the mechanical design, different designs and configurations can be achieved. However, we opted for a design that best suits our needs, such as a small design with high maneuverability, easy to manufacture, and the ability to adapt instruments in a simple and fast way. The method which is based, it will be the hierarchical method. This will help us to reduce cost by developing a customized robot, need for special tasks developed in CAD, a mechanical analysis displacement, such as von Mises stress and safety factors. The hierarchical method is quite useful for complex engineering design models, such as mathematical modeling. In high-level processes, mathematical modeling and simulations are a fundamental part of achieving a high-quality study. Experimentation with computer-aided modeling is an increasingly important problem-solving technique. This methodology stands out for its division into levels, in which the subdivision has different factors, differentiating between internal factors, which are parameters that are dependent on the level to which they are assigned, and external factors, which are parameters that are required by the next level. In this case, the mathematical modeling, each level represents an equation which is related to the next level. Here we have the table 1, which is named with cat parameters. We will see that all the variables are calculated by our program, in this case SolidWorks, and it is based on the design of the CAD. And those values are what we are going to need for our kinematic modeling. For our mathematical modeling and simulations, we got that when designing and manufacturing a robot, mathematical development becomes a fundamental part when trying to control a robot in an environment as dynamic as the ocean, which is why the need of mathematical modeling arises. Testing a robot is time-consuming and costly, and mathematical modeling is useful for simulation purposes and to design control systems that take into account the dynamic of the system. The main objective in developing a mathematical model of a robot is to achieve a complete understanding of the behavior of the robot, in this case, a submersible robot. For our mathematical model, we will be dividing it into two different parts, the kinematic model and the dynamic model. For the kinematic modeling, it will be responsible for relating every different coordinate used to represent the speed of the rod. With the model, we will know how will the rod perform on different environments. Here we got our table number 2, which is named the damping coefficient parameters. These parameters are obtained by performing the dynamic model and a polynomial regression based on simulations method. This is a proposed method. It's really something like a little bit new, and this will help us to estimate the behavior of the robot and improve the dynamic of the robot before its production. For the dynamic model, we can find that the dynamic model of the rod brings together the equation of forces and motions acting on the rod. The Newton-Euler equations of motion, which will be shown later, will help us to determine the dynamics of a submerged body. These bodies are exposed to different types of forces, and these are mainly inertial, hydrodynamic, and restorative forces. And to get an idea how the dynamic model can be started, we will present you this little equation, which is m plus d times d plus d equals tau. The m is expressed by a 6x6 matrix relating the inertia matrix and added masses. Our C variable is a 6x C matrix relating the Coriolis matrix and its added masses. D is described as a 6x6 matrix elaborated using the damping forces, and G is a 6x1 vector and elaborated using the resorting forces. All these variables added will get us to our letter tau, which will stand for the torque that we will need for our thrusters. For the fabrication, we evaluate many options for the material. In this case, we decided to work with PLA because it's a very good material. It's cheap, it's a strong material that could be printed in any type of 3D printer. The case must achieve 3 important tasks. In this case, were to perform in a good way. This being hermetic, this must be printed in PLA, basically. In this case, we need to print it in a 100% new field to get a very strong structure. And it should be a plastic shell with a very good design for achieve a good hydrodynamic. For the design, we decided to work with a 6 thrusters configuration. This for achieving 5 degrees of freedom and a better movement underwater. This to help the robot to move in different directions. In our results, for our result, we performed various stress studies, this with the intention to find if our PLA design will be able to perform the best way possible at different conditions. We started with a 10 meters of depth test, and we observed in the result that the design will withstand greater underwater pressures. So we tested at 50 and 100 meters underwater, and it performed in a very good way, and letting us know that we could raise that design up to 100 meters of depth of performance. Hydrodynamic tests were performed too, and we found that the design, based on the streamline body, obtained a 0.034 coefficient of drag. This value was even lower from the baseline of 0.04, representing us a good design with a high dynamic displacement underwater. Here we got our two graphs here representing our linear velocity in z-axis and x-axis. These were obtained using our PRBS method or polynomial regression based on simulation. And they are the linear velocity of our rod, which is an approximation of the rod behavior when it moves along the z and x-axis. For our conclusions, we have the advanced mathematical modeling, computer-aided design, CAD, and computational fluid dynamics, CFD, research have greatly improved the performance and cost effectiveness of subaquatic rods. The use of 3D printing technology has many benefits, such as the ability to precisely create custom designs with complex geometries. CFD analysis can forecast the movement of water and pressure on the rod surface, but modeling the fluid dynamics that the rod will encounter. And CFD analysis can also help improve the structural construction of the rod, such as its buoyancy and stability. Thank you.
Okay, thank you for interesting presentation. And I have one question. I wanted to clarify whether you have already created this device or the result is only at the level of computer and mathematical modeling.
Excuse me, I didn't hear you well. Can you repeat, please?
I wanted to check whether you have already created this device, this robot, yeah, physically, okay, or the results is only at the level of computer and mathematical modeling.
Yeah, all the results are based on the mathematical modeling. We get the result from SolidWorks, all the fluid dynamic tests that we did on the design. And now the project is done physically and is ready for being tested on the ocean to prove all those results.
Okay, and when we can expect the physical tests?
I think that this something.
It depends from the budget, yeah.
Well, the project is already done. The problem is that we have to take it to Europe because here in Honduras it's a little difficult, and we have to take it to Europe. So we are waiting for that, but we expect to have them soon, very soon.
Okay, very interesting project. So thank you very much. Thank you very much, and good luck for your further research. Okay, thank you.
Thank you very much.
Okay, and we have next presenter right here. So do we have, okay, we have Julius Šaulys, yeah?
Yep, hello.
Okay, hello. So could you please share your screen?
Sure.
And you can start.
Okay, so today I will be presenting our approach to evaluating deep learning architectures for recognizing environments and obstacles in robotic lawn care, and how our findings can inform the development of more efficient and effective robotic lawn care systems. So the objective of our research is the robotic lawn mower, where current solutions on the market operate using electromagnetic field generated by a signal sent from a charging station via boundary wire. This boundary wire is mounted along the edges of the lawn and defines the area in which the robot can work. So when the robot approaches this boundary wire, it receives a signal to stop, turn around and move in another direction. So the goal of our research is to evaluate different deep learning architectures for recognizing obstacles and environments in robotic lawnmower fields using AD20K dataset. By developing a system that can accurately detect objects and terrain, we hope to improve the efficiency and effectiveness of robotic lawnmowers, making them more versatile and adaptable to different environments. In order to achieve our goal of evaluating different deep learning architectures, we have identified several key objectives that we need to meet. So firstly, we need to prepare the AD20K dataset for the lawnmower robot. This involves adapting the dataset to suit the specific needs of our research by selecting classes that are relevant to robotic lawn mowing. Secondly, we need to implement and train deep learning models. And finally, we need to conduct experiments and evaluation of models in terms of accuracy and speed. So robotic lawn mowers currently on the market use a variety of sensors or combinations of them in order to navigate and operate within their designated areas. The sensors used may include ultrasonic sensor, boundary wire, GPS, RTK, or bumper sensors. But all of these sensors have limitations. So for example, ultrasonic sensor may struggle to accurately locate objects with air gaps, such as a bush. This can lead to the mower either missing the object or colliding with it, which is not ideal. So the AD20K dataset provides a total of 20,000 images. However, with 150 classes, it contains many of them that would not be relevant to a robotic lawn mower. So in order to make the dataset more applicable to our research, we decided to trim it down to a subset of 21 classes that are the most relevant in this research. So additionally, we categorized each of these classes into one of three categories: cuttable, drivable, and obstacles. The cuttable category contains classes such as grass and weeds, which can be cut by the lawnmower. The drivable category contains classes such as pathways, road, which can be driven on. And finally, the obstacle category contains classes such as flowers, toys, which the lawnmower needs to avoid. So for our comparative analysis of deep learning architectures, we have chosen 6 models. All of these models use Exception 65 backbone, and we have also included MobileNet backbone for deep lab model in order to validate our implementation and results against different research and semantic segmentation field. 2 evaluation metrics were used during this research, so pixel accuracy and mean intersection over union. Pixel accuracy gives a straightforward measure of the number of pixels that were accurately predicted, while mean intersection over union provides a measure of how closely the predicted pixels align with the actual objects in the image. We have trained before mentioned models on 3 different dataset groups. First one with original 150 classes, then a 21 class subset, and finally 3 categories that were created from the 21 class subset. On the left, we can see pixel accuracy charts, and on the right, mean intersection over union. So starting off with the results, 150 class results on average 60% in pixel accuracy, while best results were obtained using deep lab exception model with a pixel accuracy of around 76%, which is almost identical as FCN. However, mean intersection over union is ranging from around 15% to 42%. So going down to 21 class subset, results are immediately better. All models managed to reach 70% on average in pixel accuracy. Mean intersection over union also saw an increase of accuracy, with bottom half of the models reaching 35% and best ones 58%. Top 3 models remain consistent in terms of ranking. And finally, using 3 categories, best models managed to achieve 92% pixel accuracy and around 80% mean intersection over union. Initially, using 150 class dataset, the models on average achieved a pixel accuracy of 71%. However, after trimming it down to the dataset to 21 classes, the accuracy increased to around 80%. And after merging 21 selected classes into 3 categories, pixel accuracy of the model further improved to around 88%. Mean intersection over union also improved as the amount of classes was reduced. Accuracy increased from around 28% to roughly 45% when using 21 class subset, and improved significantly to 72% when using 3 class subset. Due to the limitations of the hardware, we have also analyzed inference speeds for each model and their respective accuracy using 3 class subset that we discussed just before. So top 2 most accurate models were FCN and DeepLab, with the exception 65 backbone. They each take around 6 to 8 seconds to complete inference. While using a smaller backbone such as MobileNet, it was possible to achieve around 2-second inference speed and only reduce the accuracy by 2 percentage points. Other models were faster at inference, but their accuracy was not high enough, so even changing their backbones to MobileNet would further decrease their accuracy. Additionally, trained models underwent visual inspection. So in first example, it is using highly accurate model using 3 class subset, where in the first image we can see predicted mask, and on the second image actual mask. And in the second example, we can see a model that performs significantly worse as there are only traces of obstacles. So for the conclusions, we have evaluated models that managed to reach 92% in pixel accuracy and around 80% in mean intersection over union. Cuttable surface class was recognized with 98%, drivable with 85%, and object detection saw 99% accuracy. Reducing the number of classes in dataset was a successful strategy that led to a significant improvement in accuracy. Although the best models were FCN and DeepLab, with the exception 65 backbone, changing the backbone to MobileNet saw 2 percentage point drop in accuracy, but increasing inference speed by 3.5 times. And it would prove useful to further analyze accuracy and inference performance by evaluating different backbones. Thank you.
Okay, thank you for interesting presentation, and I have a question. And could you please name the most important and the most significant result of your research? One of them.
Yeah, so the most shocking one was that the best models obviously took longer, but just changing the backbone to MobileNet, here we saw like only 2% decrease in accuracy, but the inference speed was 3.5 times faster. So this is really efficient model and backbone setup from what I have found during the
And okay, and how you plan to put it into the practice?
So we plan to put it into the practice by testing out various microcomputers or microchips to put the best models from this table and see what's the inference speed for each of them. So obviously something like 8 seconds is not interesting, but something like 2-3 seconds or so would be, I think, pretty significant.
Okay, so thank you for interesting presentation. And okay, so we do not have on site one of our presenters of this section, Dalius Gudeika. Or we have? No, we don't have. Okay, so according to our schedule, we will have 40 minutes short break, and we will continue our special session on intelligent systems and e-learning solutions part 2 at 4 p.m. So we have 40 minutes short break. Okay, see you. Thank you. Okay, dear colleagues, hello. So now we have 3 participants from the listed 4, which is the final one. So we have on site Eimantas, Ali, and Rodrigo. So maybe we can start a bit earlier. Are you ready?
Sorry, I'm waiting for a few of my colleagues to present as well together with me.
Okay. Okay, so Eimantas, when you will be ready, please inform me, okay?
Yes, okay.
Okay, great.
Excuse me, Professor, did you call?
Sorry?
Yes, Professor, I heard my name. Did you call?
Yes, I proposed that maybe we can start earlier, but the first presenter informed me that is waiting for colleagues, so we will wait a bit, okay?
Okay, okay. Thank you.
No problem.
My colleagues are here, so we can start.
Okay, Monte. So let's start our special session on intelligent systems and learning solutions, part 2. So, okay, could you please share your screen and please go on.
Good day, everyone. I hope you see the slides. And my name is Eimantas. Together with my colleagues Dmitra and Bogdan, we will present to you today a framework for microbusiness density forecasting.
Hello, everyone. To begin with, let's get a clear view of what microbusiness is. It is a type of small business that has fewer than 10 employees. And over the past few years, there has been an increasing focus on the density of microbusinesses in the United States. Next, I'd like to share some information about the data assets that Venture Forward team has produced. This team at GoDaddy was working on gathering data about tens of millions of microbusinesses in the US. The competition they initiated aims to forecast the monthly density of microbusinesses throughout the United States. And on the left of the slide, you can see the microbusiness activity index across the United States. At first, we were provided with the initial data of access to broadband, population over age of 25 years with a 4-year college degree, percentage of foreigners, percentage of workers in IT sphere, and the median household income in the county. On the right side of the slide, you can see that all this data was followed by SFIPS, which is a unique identifier for each county. And additionally to initial data, we were encouraged to use any other useful data that we could find. We have performed a literature review regarding market business density researches, and it turned out that it is a relative new topic which doesn't have much studies for now. Microbusiness density has been the subject of interest only in Great Britain by the University of Kent. They worked on determining the factors that influence local microbusiness density and factors that are influenced by it. And the results of University of Kent really helped us to determine the additional useful variables that we can use to improve our predictions accuracy. It showed us that there is a significant relationship between microbusiness density and next variables that you can see. That is employment level, population density, business turnover, gender distribution, prosperity indexes, internet usage data, and distribution of ethnic groups. Fortunately, all this data is publicly available, so it was really easy for us to add it to our predictions.
For prediction evaluation, the organizers of competition required us to use semantic mean absolute percentage error, which equals 0 when the predicted value and actual value are equal. Slide. Pearson correlation was used for during exploratory data analysis to better understand data distribution of initial data set. Next slide. After we combined all the data we had, we normalized it via given formula. Next slide. Akakia information criterion was later used to evaluate variables which are important and which are not. We also used chi-square for the same purpose to ensure accuracy of our findings and not make a mistake with chosen variables. Next slide. Elbow method was then used for clustering analysis to find out what variables and what clusters and how much of them are needed to optimize the results. Davis-Baldwin score was used for the same purpose, but it gave more promising results, which were later used for during our work.
After completing literature review and performing and deciding on the methods we used, we started with explanatory data analysis, where first thing we did was check the distribution of the features. We determined that the distribution is close to a normal distribution, so that meant that we for sure can use Pearson correlation to check the dependencies between the features. And after performing Pearson correlation, we found out that between all the presented features, there was a weak to medium
linear dependency where person correlation coefficient was between 0.2 and 0.7. Then we noticed that there are 7 states that had bigger average of microbusiness density than the rest of the data set. The 7 states mentioned in the slide had an average of 10.8 microbusiness density, had 10.8 average microbusiness density between them, while the rest 45 states had an average of around 3.2. We also noticed some small seasonality between the observations, where we can see the increase of micro businesses during the festive period. After explanatory data analysis, we moved to data preparation, where we combined training and testing dataset provided by the competition organizers. This step was taken mostly to simplify the process of introducing lag terms. Then we moved on to introducing lag terms, and we choose to add 1 year of microbusiness density lag. We imputed missing values. We also split the combined dataset back to the training dataset and testing dataset. The training dataset was used for training our models and validating models' accuracy, and the testing dataset was used to make a forecast of micro businesses and submit it to competition for evaluation. After that, we removed features with incomplete lag terms. Because we chose 1 year of lag, that means that the first 11 observations had incomplete and no other feasible way to fill them in. After removing the incomplete features, we scaled numeric features to make them all be between 0 and 1 inclusively. We also prepared additional data set where we transferred micro business density, or aka our target feature, using logarithmic transformation. This helped us to determine which dataset was more suitable for our predictions. And finally, we used one-hot encoding to encode all the categorical variables. This made our datasets pretty big, and each dataset had over 3,000 features. That's why we needed some feature selection, and we chose to complete feature selection by using stepwise feature selection procedure with the ordinary least squares regression test, where p-value for statistically significant feature was chosen to be 0.05. Finally, after feature selection, we had 21 statistically significant features that we used in our modeling experiment. With the experiments, we noticed that using original data set, we achieved the best results using multi-layer perceptron, and while using logarithmically transformed data set, the models worked best for us was linear and ridge regressions. Sadly, when we submitted the results to the competition for evaluation, we see a different result. And the final model we used for this competition was XGBoost regressor. We had to predict 6 months in advance. And because we had introduced lag terms, we had to predict month by month for each county. And after each prediction, we had to update our lag term variables. In conclusion, with explanatory data analysis, we've seen a positive relationship between microbusiness density, college education, broadband usage, and median income in households. To account for the fluctuations, we performed cluster analysis using k-means algorithm. We also identified 21 statistically significant features that we used later in our experimentations, and the best model was XGBoost regressor with a SMAP of 3.3159. Thank you for your attention. We are ready to answer any questions.
Okay, thank you for interesting presentation. And what I would like to ask about the practical implementation side. What is the status?
Well, it's really hard to talk about practical implementation because since the ending of the competition, 5 major US banks went bankrupt. So basically, this situation was not in any way, shape, or form reflected in the data we used.
So, but you know, it is no, how to say, in the life, it happens, yeah, that we have positive waves in business, negative waves in business. So, you know, it is very sensitive, yeah.
Yes.
So it is not good practice to, you know, to build the kind of solution only on this, let's say, trends when the business grows up, yeah, or not?
Yeah, but it would also help to have some representation of the bad times to make more suitable predictions. But for example, if we had all the data we need, and let's say that hypothetically, the implementation would help government bodies to closely monitor micro businesses and help make decisions, including them in the grander scale.
So the government will have kind of dashboards, yeah, kind of dashboards monitoring the micro business kind of health or something, yeah.
Yeah, it could be one of the implementations that way.
Okay.
It also would help for hosting providers to plan better for the resources they have and they can offer for the public.
For kind of business angels, yeah, or something to have to provide the right decision to invest or not, yes, something like that.
That, and also, for example, the hosting provider like GoDaddy, who organizes competition, they could plan into the future how many servers they would need, how much broadband they would need also.
Okay, interesting research. Okay, thank you very much. Thank you. And our next presenter will be Ali. Okay, we can see Ali. Ali, could you please share your screen? Okay, we can see your slides.
Okay, thanks. Hello, I am Adi Azadi, PhD student of the Salamanca University, and I have done this study with getting help from my supervisor, Professor Pinalvo, in the Guerrilla group, and we are talking today about the unpacking the evaluation processing of clinical decision support system review of methodological approaches and categories. At first, let's see why the CDSS must be evaluated. So, computer programs to be boost medical decision system have long been anticipated by physicians with both curiosity and accuracy. And to ensure that clinical decision support systems have been effective at improving patient care and safety, raising the standards of care, lowering the healthcare costs, and boosting healthcare providers' productivity. And in addition, we should done it because to guarantee the results reliability and validity and allow for the generalizability of findings to the different contexts. So selecting the best methodology for evaluating CDSS is a crucial point in investigating these systems, especially about the medical information systems. And there are two main aspects that it can be evaluated by the assessors in different aspects, like usability aspect and accuracy level of the aspect of the CDSS. About the usability methods, there are two main categories, which are called single one methods and multimodal methods. It means that sometimes one model concretely can be used to evaluate the CDSS, and sometimes combination of the methods can be used to evaluate this kind of the systems. About the single one methods, there are some different methods like think aloud. Users are asked to think aloud while completing the task, while they are performing the daily tasks in the work environment. And about the near live, every participant demonstrates the same workflow regarding the order of the events. And another method is heuristic evaluation. A small group of usability experts evaluate user interfaces against a set of guidelines. Another solution, another method is cognitive walkthrough. It's a usability inspection method for its ease of exploratory learning based on cognitive model of learning and use. Another solution and method, pluralistic usability workflow. It's a method to include representative users, product developers, product team members, and usability experts in this process. Another method, which is called a formal usability inspection. A formal usability test reviews the user potential tasks performance by an interface designer and their peers, aiming to identify the maximum number of errors in the interface. And after performing and implementation of the CDSS, sometimes we use quick and dirty usability testing. It means that it is impossible to characterize a system's usability without first identifying its intended users, specific users. In this system usability scales, we use a Likert scale. It means that responder is asked a statement and then asked to rate how much they agree or disagree with this platform. It is prepared CDSS systems, and there are some questions, about 5 questions and sometimes 7 questions. Sometimes we use multimodal methods. It's mixed kind of another methods. For example, development and design approaches. The optimal design approaches for CDSS developers comprise iterative development, user-centered design, collaborative design teams, and usability inspection, clinicians interviews, log analysis, and cognitive workflow as the principal component. Sometimes we integrate two another methods, for example, think aloud and near live. We have to do these methods, but in a specific respectively. For example, at the first phase, testing human-computer interaction associated with think aloud protocol analysis to evaluate, and after that, a near-live clinical simulation in assessing how stakeholders interacted with the system while interviewing a simulated patient. About the accuracy level methods, we use sometimes statistical analysis for happened errors, sometimes positive and negative predictive value, and sometimes comparison with golden standard. It means sometimes a standard method will be used to compare the error cases that have been taken place to calculate a risk score manually and by CDSs. And sometimes in another method, some of the monitoring and critical values have been defined to calculate accuracy, sensitivity, and specificity to review other screening performance characteristics. And sometimes there are a golden standard for a specific test to compare other automated medical functionalities with the ideal one. In other words, an expert prepared a golden standard for making diagnosis was verified in an earlier investigation. As a conclusion, we can say that if CDSs are assessed perfectly, successfully, will lead to widespread acceptance by the users, by the physicians, and improve patient outcomes. And these kind of studies, by collecting various evaluation methods, categorizing, comparing their exclusive attributes, specific abilities, will help assessors to choose the best and the optimized option according their needs, according their specific circumstances, and help the doctors and decision makers in the medical environment. Okay, thank you very much for your time and your attention.
Okay, could you please open a conclusion slide? Yeah, okay. Yeah. I would like to exact, it sounds very interesting. What you mean in the last conclusion will help the assessors to optimize for the most optimized option according to the specific circumstances. Could you please explain?
Yeah, of course. For example, before the implementation of the CDSS environment and platform, we can use some optimized methods. For example, near live methods. It means that we can simulate the real environment for the patient, for the doctor, and we can predict some of the errors maybe happen in this implementation. Mm-hmm. And sometimes after the implementation, we need to choose another solution to evaluate our platforms. For example, near live, it is not a suitable solution for this kind of the evaluation. And for example, quick and dirty solution is better. So,
yes, I understand. Do you have kind of example related with your research?
Related is for example, in the reality, we have a successful implementation in an infertility center in our country in Iran, and after implementation, we have done quick and dirty evaluations to getting feedback from the physicians about the platforms, because the user-friendly aspect for the CDSS and for the medical information systems is very important to collaborate with the doctors and to, for example, data entry for the gathering data from the medical information systems is so crucial. So we have used in the reality.
Yes, okay, it's clear. Thank you very much. Thank you very much.
You're welcome. Thank you.
Do we have more questions? No, I can see. Okay, thank you very much for interesting presentation.
You're welcome. You're welcome.
And our next presenter should be Rodrigo.
Yes, Professor. Give me a second. I'll just.
Can you hear me?
Yes, of course.
Okay, so could you please share your screen?
Of course. Give me a minute. Yeah. Okay. And this is one. Okay. Can you see?
Yeah, we can see it.
Okay. Just give me a second to get into presentation.
Okay, perfect.
Okay. Oh, sorry. So soon. Okay.
Chocolate is okay.
Yeah. Good morning to everyone. Today's presentation will be about the project quality control process for cocoa beans through computer vision concept. The project's team members were Jose Luis Ordóñez, Angie Carolina Santos, Marilena Perdomo, and yours truly, Rodrigo Espinal. I know most of you, if not everyone, has eaten one of these, a delicious chocolate bar. Chocolate is one of the many products made from cocoa beans. To ensure these products have an excellent quality, the cocoa beans used to make them need to be of excellent quality. There are several procedures currently used to assess the quality of the cocoa beans. One of the methods is known as the cut test, which is based on color changes registered during fermentation. Another method is a visual test, where the person in charge observes the outside of the bean for physical defects and determines its quality as good or bad. However, these methods are quite subjective as they depend on the farmer's experience and judgment. The objective of this research was to develop a computer vision algorithm and an artificial neural fuzzy inference system that helps and determine if it is a viable implementation in the quality control process of cocoa beans by classifying them based on their quality. The experiment, as the methodology, was conducted in 3 stages. Stage 1, data collection and preprocessing. Stage 2, artificial neural inference system model, or ANFIS to say it easier, and model evaluation. So first, with data collection and preprocessing. Data collection. During our data collection process for this experiment, it was a crucial step in ensuring the data accuracy and reliability of the results. To gather a sample of cocoa beans, we visited the Association of Agroforestry Producers of the Choloma River Basin, a group of farmers who specialize in producing high-quality cacao beans. With the cooperation of the farmers, we were able to collect a total of 198 photographs of cocoa beans, carefully selected to represent both quality and poor quality beans. To ensure consistency in our data collection process, all photographs were taken at the same distance and under the same lighting conditions, minimizing any potential sources of variability that could affect the quality of the images. Due to the distance of the agroforestry producers of Choloma, we were only able to take 198 pictures. Our intent was to take many, many more, but that's all we were able to get in the short time frame we got there. But furthermore, the poor quality beans were classified based on their physical deformations, which included flat cocoa beans, multiple united cocoa beans, broken cocoa beans, and sprouted cocoa beans, as shown in figure 1. Here are the good, the flat, the broken, united, and sprouted. Then, the data preprocessing was a process in which we aimed to ensure that the extracted features of the beans were accurately and reliable. To achieve this, we performed several operations of the collected images. First, we resized the images to a uniform size to facilitate their analysis. Then, we applied several filters, including grayscale, threshold, and medium blur, to enhance the image quality and facilitate feature extraction. We also use the cutting edge detection algorithm to accurately detect the contour of the cocoa beans. This allows us to extract 3 features: contour area, surface area, and perimeter of each bin by using the open CV functions, cv.contour area, cv.arclength, and MP histogram, as shown in figure 2, the preprocessing of algorithmic flowchart. Then, our next step after obtaining these three features, we use them to feed an artificial neural fuzzy inference system model. These three inputs were used for the model to determine if the bins were either good quality or bad quality. We used 174 pictures of cocoa beans for training, and we used 24 bins for evaluation. So in the model, we process the inputs, and it was trained with 500 epochs to obtain the network shown in figure 3. Each input variable has its own set of membership functions, one for each class. These membership functions are often graphically represented, with the x-axis representing the input value and the y-axis representing the membership degree. In this model, it generated 27 rules for handling quantitative formulation between contour area, surface area, and the bin perimeter in predicting the quality of cocoa beans. The relation between the inputs and the outputs is shown in figure 4 as a surface graph showing the inputs and outputs based on the membership function and fuzzy rules. Then, for evaluating the performance of this model, we used the 24 cocoa beans which were not included in the training sample. The Gaussian membership function was found to perform optimally, correctly classifying. Okay, sorry. Sorry for that. I skipped the slide. For our metrics for evaluating this model, we used accuracy, sensitivity, specificity, false positive rate, recall, and we calculated the F1 score to evaluate our model. Then for our results, the algorithm to evaluate the performance, it correctly identified 14 bins as positive and 10 as negative. Of the 14 positive identified, 12 were correctly identified as true positive, while all 10 bins that were bad were correctly identified as true negatives. The model produced 2 false positives and 0 false negatives. A summary of these results can be found in table 1 and here on figure 5, which we have here the confusion matrix. As you can see, 12 were classified correctly as positive and 10 were classified correctly as negative. As where we have two errors were in here we can see the results in here. Now, for the evaluation results, according to the metrics shown earlier, our accuracy was of 92%, our sensibility was 100%, our specificity was 83%, our false positive rate was 17%, our precision was 86%, our recall was 100%, making an F1 test of 92%, making this a viable method. So, as to conclude, a computer vision algorithm was developed to classify the cocoa beans according to their physical defects, achieving an accuracy level of 92% and eliminating subjectivity in the classification process. This study compared very well with previous study on agro-product defect detection in Honduras and had a huge potential for low-cost implementation, optimizing time, and enhancing the quality of cocoa bean classification. And future work could focus on improving the accuracy of the algorithm by incorporating more training data, fine-tuning parameters, and exploring other techniques, and considering additional factors that may affect the cocoa bean quality. Thank you very much for listening. If you have any questions, please feel free to ask.
Okay, I have one question. For example, is it very possible to reuse the knowledge of this method for example, quality control process of, I don't know, of banana, grapes, pineapple, or different cultures? Is it possible or not? Or it is very, very specific knowledge and process related things?
No, it's very possible. Actually, there are various studies which involve bananas. Some, in these cases, I made the study of the cocoa bean. There's other study relating the fruit itself of the cacao fruit, which was made by. There was also a similar study made with coffee, also here in Honduras, made by one of my colleagues. There are various studies, and this is a very growing field according to quality on agro products. Especially here, which experience has such a huge impact in this industry. Some people need to be trained to correctly classify a fruit or vegetable, or in this case, the cocoa bean, as either good or bad. And the people need to have experience. Some people are paid very well for this kind of job because it's very important. For example, the chocolate bar, it needs to have a very specific, very good cocoa bean quality.
Okay, and what do you think about the commercialization of such proposal in the, kind of specific software or something?
I think it is a very good opportunity, especially since these computer vision algorithms can be used with smartphone cameras. And it could be a huge opportunity, especially for third world countries like my own in Honduras, and also for everyone really. It is a very good and exciting opportunity.
Okay, thank you. Do we have more questions? No. Okay, and we should have the last presentation, which should be presented by Valentin Redondo Blasco, but I can't see him right here. So I think that's it. So thank you very much. Thank you very much for patience. Thank you very much for, in general, very interesting presentations. I think that it was beneficial not for me but for you as well. And thank you very much for participation. And I'm looking to see you next year in the same conference, or maybe we will meet somewhere else in kind of different events or project meetings or conferences or I don't know, other kind of events. So thank you very much for participation. And so have a nice weekend. Goodbye.